In 1933, a French military officer named Conrad Killian was flying over the Sahara Desert on a routine reconnaissance mission when he looked down and saw something that made no sense. He wasn't looking at the endless sand he expected. He wasn't tracing the familiar emptiness of the world's largest hot desert. He was staring at rivers. Not dry riverbeds, not ancient cracks in the earth that might once have held water 1,000,000 years ago. Rivers. Vast branching networks of channels so enormous they were visible from the air, carved into the bedrock beneath the sand, with the unmistakable geometry of flowing water. The geometry of movement, of life, of something that had once been utterly, gloriously wet. He landed, he investigated. He filed a report that was largely ignored for decades because the idea was simply too strange, too incompatible with everything people believed they understood about the Sahara. But Killian wasn't wrong. He was just early. What he saw from that cockpit in 1933 was the ghost of a world so different from our own that it sounds like mythology. A world where the Sahara Desert, the largest hot desert on Earth, the place where temperatures crack 130 degrees Fahrenheit, where almost nothing grows, where the landscape looks more like Mars than Earth, was green. Not slightly green, not green in patches, green the way the Amazon is green. Green the way Ireland in May is green, soaked through, impossibly lush, dense with life from the ground to the canopy. Covered in lakes the size of seas, rivers wider than the Mississippi, forests that stretched for hundreds of miles, grasslands so thick with animals that they made the modern Serengeti look sparse. This world existed. The evidence is everywhere, buried just beneath the surface of the sand that swallowed it whole. And the question that keeps me awake at night isn't whether it existed. That part we know. The question is, what happened to it? What killed the greenest, most alive version of the Sahara? How does an entire world that size simply vanish? And what does its disappearance tell us about the razor-thin thread on which all civilization, including ours, is suspended? This is not a story about ancient geology. This is not a story about things that happened so long ago they don't matter anymore. This is a story about change, about how the richest places on Earth become the emptiest, about how the forces that shape and destroy worlds are operating right now, around us and inside us and in the systems we depend on. This is a story about what we've lost, about what we might lose, and about the extraordinary human communities that flourished in the Sahara for thousands of years and left behind a record so detailed and so beautiful that scientists are still reading it, still being astonished by it, still finding in it evidence that rewrites what we thought we knew about the origins of civilization itself. This is one of the most important stories you've probably never heard, and it starts not in a library or a laboratory, but in the sky, with a confused French pilot looking down at rivers in the desert and trying to understand what he was seeing. Let's start at the beginning, because to understand the Green Sahara, you have to understand something fundamental about the way the Earth itself breathes. The planet doesn't sit still. It wobbles, it tilts, it rocks in its orbit around the sun like a spinning top that's starting to slow down. And these tiny, almost imperceptible movements so slow that they play out over thousands of years, have consequences so enormous that they reshape entire continents, grow glaciers the size of countries, and turn deserts into gardens, and gardens into deserts. The technical term is orbital forcing, and the science behind it is named after the Serbian astronomer Milutin Milankovic, who spent the years between the world wars doing something remarkable, calculating by hand on paper how variations in Earth's orbit and axial tilt would affect the distribution of solar energy across the planet's surface. He did it for the past 600,000 years. His calculations, largely ignored during his lifetime, were vindicated spectacularly in the 1970s when geologists found that the timing of ice ages in the sediment record matched his predictions almost perfectly. The Earth's climate dances to the rhythm of orbital mechanics, and the dance has been going on for billions of years. The variations that matter for the Green Sahara are primarily two: the precession of Earth's axis, which operates on a roughly 26,000-year cycle and determines which hemisphere leans toward the Sun during which part of the year, and the eccentricity of Earth's orbit, which changes how elliptical or circular the path around the Sun is. These are slow dances, too slow to see in a human lifetime, too slow to notice in 100 human lifetimes. But their consequences are planetary. About 11,000 years ago, Earth's axis was pointing in a different direction relative to its orbital position around the Sun, and the result was that the Northern Hemisphere summer happened when Earth was slightly closer to the Sun than average. This meant more solar energy hitting the Northern Hemisphere during summer. Not a lot more, we're talking about a few % difference at most. But the African climate system is exquisitely sensitive to this kind of forcing, and those few extra % made an extraordinary difference. The African monsoon, the massive seasonal wind shift that drives rain across Africa from the Atlantic and Indian Oceans inland, pushed north. Normally, the monsoon dies out somewhere around the Sahel, the scrubby band of semi-arid land at the southern edge of the Sahara, the place where green reluctantly shades into yellow, then brown, then nothing. During the African humid period, the Green Sahara period, the monsoon didn't stop there. It kept going, north, deep into what is now desert, all the way to the Atlas Mountains on the Mediterranean coast, all the way into the heart of the Sahara, into places that today receive less than 1 inch of rain per year, that then received enough rain to support forests. This wasn't a light drizzle. This was a transformation, a fundamental reimagining of what the Sahara was and what it could be. The Sahara was receiving somewhere between 5 and 10 times more rainfall than it does today, every single year, for thousands of years. 5 to 10 times. Stop and sit with that number for a moment. If a region that currently receives 2 inches of rain a year were suddenly receiving 15 or 20 inches, consistently, year after year, decade after decade, it would not simply become more comfortable. It would become almost unrecognizable. Rivers would form, lakes would fill, soils would develop, vegetation would establish, and as vegetation established, more moisture would be retained and more rain would fall, and more plants would grow in a spiral of increasing life that, once started, can sustain itself for millennia. And the land responded the way land always does when given the water it craves. It exploded into life. This is what scientists call the African humid period. And it lasted, with regional variations in intensity and timing, from roughly 11,000 years ago to about 5,000 years ago. 6,000 years. 6,000 years of green. 6,000 years of lakes and rivers and grasslands and forests in a place that most people today know only as the world's most forbidding desert. And during those 6,000 years, something else was happening alongside the biological transformation of the landscape, something that changed the course of human history. People were living there, not just surviving, living, building communities, creating art, developing culture, domesticating animals, establishing trade networks, raising their children at the edges of great lakes and along the banks of vast rivers that no longer exist. The story of the Green Sahara is, at its heart, the story of a human civilization that flourished in one of the most unexpected places imaginable and then watched its world disappear. The scale of what we are talking about needs to be felt, not just understood abstractly. The Sahara Desert is larger than the continental United States. It covers 3.5 million square miles. When scientists say the African humid period turned the Sahara green, they are saying that an area the size of the continental United States, every inch of it, from the Atlantic coast to the Red Sea, from the Mediterranean coast to the Sahel, was transformed from the world's most hostile landscape into one of its most productive ones. The breadth of this transformation challenges the imagination in a way that few facts about the natural world do. And yet it happened. It happened in the lifetime of our species. It happened within the span of modern human culture. The people who witnessed the Green Sahara were people who thought the way we think, who felt the way we feel, who loved their children and their animals and their landscapes the way we love ours. They are not distant strangers. They are our ancestors, separated from us by a gulf of time that is meaningful but not unbridgeable. Their world is gone, but their story is ours to inherit and to learn from, if we are willing to look. And the looking, as I hope this journey has shown, is one of the most extraordinary things a human mind can do. It is also, I have come to believe, one of the most necessary. To understand what we have lost is to understand what we still have. To understand what was possible is to understand what might be possible again. The Green Sahara is not a story about the past. It is a story about the future we are still choosing. Picture what the Sahara looked like 11,000 years ago. And I mean really picture it, because what the evidence shows is so different from the landscape, we know that your brain will resist accepting it. The resistance is natural. We have a tendency to see the present as the default, to treat the world as it is now as the world as it must have always been. The Sahara is so definitively the Sahara, so associated in our cultural imagination with heat and sand and absolute dryness, that it requires a real act of mental will to replace it with something green. But do it anyway, because what was there is worth seeing. Where the Sahara now covers 3.5 million square miles of sand and rock and bone-dry plateau, there were lakes. Not small lakes, not ponds. Lakes the size of modern countries. Lake Megachad, which occupied the basin where the modern, shrunken Lake Chad now sits, was at its Green Sahara peak the largest lake in the world. Larger than the Caspian Sea. Larger than all of the Great Lakes of North America combined. It stretched across parts of what are now 4 different countries: Niger, Chad, Nigeria, and Cameroon. And it was deep enough, stable enough, and old enough to develop its own distinct ecosystem of endemic species that evolved specifically in its waters. When you look at modern Lake Chad today, a shrinking, stressed remnant of that ancient giant, and you understand what it once was, the sadness is very specific and very heavy. But Lake Megachad wasn't alone. There were hundreds of lakes scattered across the Sahara, from Morocco to Egypt, from the Mediterranean coast to the Sahel, connected by rivers that scientists have now mapped in breathtaking detail using satellite radar data that can see through the sand to the riverbeds underneath. When NASA's Space Shuttle Columbia flew its first shuttle imaging radar mission in 1981, the signals it sent toward the ground had a remarkable property. Sand is surprisingly transparent to radar. The system's radio waves penetrated through the dunes, in some places through several meters of sand, and bounced off the harder rock beneath, sending back reflections that revealed the buried landscape of the Green Sahara. Channels, valleys, drainage networks, river systems of extraordinary scale, carved over thousands of years of flowing water, and then buried under the dunes that came after the water left. Scientists stared at these images in something approaching shock. The radar revealed beneath the hyper-arid eastern Sahara, beneath the part of the desert that today may not see rain for a decade, a complete ancient drainage system. One system alone drained an area of over 400,000 square kilometers and flowed north into the Mediterranean. It was one of the major rivers of the ancient world. It no longer exists above the ground. The sand ate it slowly over thousands of years, grain by grain, dune by dune, until the living river was transformed into a fossil of movement, a record in stone and sediment of the water that once ran through it and the life that followed. Since 1981, the radar mapping has continued with increasingly sophisticated technology, and what it has revealed is a picture of hydrological abundance so extraordinary that even climate scientists who have spent careers studying the Green Sahara sometimes struggle to fully internalize what the data is showing. There wasn't one major buried river system. There were dozens. Some of these buried rivers had watersheds comparable to the modern Amazon or Congo. Vast drainage basins that collected rainfall from enormous areas and channeled it through channels scores of meters wide and several meters deep into the great central lakes. The Wadi Hawa in Sudan was once a river as substantial as the modern Rhine, flowing northwest through what is now one of the world's most uninhabitable zones. The Kufra Basin in Libya, today a remote, barely accessible wasteland, was once a lake system that covered tens of thousands of square kilometers. The Fezzan region of southwestern Libya, one of the driest and most remote areas in the world, was once a landscape of interconnected lakes and rivers supporting dense vegetation and abundant wildlife. To appreciate what all of this means, you have to understand the modern Sahara first. The Sahara today is not uniform. It contains different kinds of desert. The great sand seas called ergs, where the dunes can be hundreds of feet high, and the sand goes on for hundreds of miles without a break. The rocky plateaus called hamadas, where bare stone extends to the horizon, with almost no soil and almost no life. And the gravel plains called regs, flat and featureless, and baking under a sun that, this close to the equator, is almost directly overhead for weeks at a time. Rainfall in the central Sahara averages less than 1 inch per year, and in the most arid areas it may not rain at all for years or even decades. What the radar images reveal is that beneath this landscape of absolute dryness, there is the shadow of a completely different world, imprinted in the rock by thousands of years of abundant water. The world that cast the shadow has been gone for 5,000 years, but the shadow remains, legible from space to anyone who knows how to read it. The animals come next, and this is where the story becomes almost hallucinatory in its richness, because the fossil record from the Green Sahara isn't a sparse collection of fragments. It's a zoo, an entire, teeming, impossibly abundant zoo buried under the sand, waiting for the right questions and the right technologies to bring it back into the light. In 2008, a paleontologist named Paul Sereno led an expedition into the Sahara Desert in northern Niger, one of the most forbidding places on Earth, a region so desolate that the Tuareg call it the desert within a desert. The Tenere today is so dry, so featureless, so utterly hostile to life that even the sand dunes seem reluctant to form. The surface is mostly flat gravel interrupted by occasional rock formations, sculpted into impossible shapes by millennia of wind. Sereno's team was looking for dinosaur fossils. They found them. But what they didn't expect to find was evidence of one of the most significant human habitation sites ever discovered in the Sahara. They called it Gobero, and what it revealed was extraordinary. But before we get to Gobero, let's talk about the animals themselves, because the zoological evidence of the Green Sahara is scattered across thousands of sites, collected over decades by researchers who sometimes spend months in the desert to find a handful of bones that tell a story larger than any museum could contain. Let's start with the hippopotamus. The hippopotamus needs permanent deep water to survive. It spends most of its day submerged to regulate its body temperature. Its skin, despite appearances, is highly sensitive to the sun and requires constant moisture. A hippo without a river or a lake is a dead hippo, and dead hippos don't last long in the desert. Yet the bones of hippos have been found at Saharan sites from Mali to Sudan, from Algeria to Chad. Not one site, not two sites, dozens of sites. Hundreds of individual animals whose remains are now being recovered from the sand of one of the driest places on Earth. Each set of hippo bones is a data point about the water supply. If hippos were here, there was permanent, deep, reliable water here. The hippos are not lying. The hippos are very specific. They tell you something happened to the water that used to be here. The crocodiles tell the same story with an even greater specificity, because modern crocodile populations in Africa are genetically connected in ways that tell you something about how the ancient populations were distributed. The Saharan desert crocodiles, small relic populations that survive today in remote mountain pools in Algeria, Mali, and Mauritania, cut off from all other crocodile populations by hundreds of miles of desert, are genetically related to populations in sub-Saharan Africa, which tells you that they were once part of a connected population that ranged across the entire Green Sahara when the water that connected them was still flowing. They didn't arrive in the mountains. They were left there when the water retreated, stranded survivors of a hydrological network that was once so complete that crocodiles could travel from the Atlantic coast to the Nile without once being out of water. They are still there. They are still alive. They have been isolated in those mountain pools for more than 5,000 years, surviving in water sources so small that the global population of Saharan desert crocodiles may number in the dozens. They are the loneliest animals on Earth. They are the last survivors of the Green Sahara's wildlife. And then there are the elephants, the giraffes, the lions, the leopards, the cheetahs, the African wild dogs, the zebras, the wildebeest, the many species of antelope and gazelle, the warthogs, the baboons, and the dozens of smaller species. Mongooses, jackals, foxes, hares, lizards, snakes, that would have made up the complete ecological community of a thriving savanna. The fossil record for most of these is less complete than for the hippos and crocodiles, partly because their bones are less robust and don't survive burial as well, and partly because many of the richest Green Saharan sites have simply not been extensively excavated. The sites that have been worked carefully are almost invariably astonishing, and the emerging picture is of a Saharan fauna that was, at the height of the African humid period, essentially indistinguishable from the fauna of the modern East African savanna. An ecosystem of comparable richness, comparable diversity, and comparable productivity, spread across an area 3 times larger than East Africa today. 3 times larger. We are talking about one of the greatest wildlife habitats in the history of the Earth, at a time when human beings were first developing the cultural tools that would allow them to observe, record, and celebrate the natural world around them. And they did observe it, and they did record it. The evidence of what they saw and felt is still there, written on the walls of rock that outlasted everything else. In the Tassili Naja Plateau in southern Algeria, a landscape of eroded sandstone towers and deep shaded canyons that is itself one of the most beautiful places on Earth. There is a gallery of rock art so vast, so detailed, so technically sophisticated, and so relentlessly alive that it has been called the greatest outdoor museum in the world. The paintings and engravings cover thousands of rock surfaces across an area hundreds of miles wide. They were made over thousands of years by dozens of different cultures, and together they document in meticulous, loving detail the world that the Sahara once was. There are elephants painted with such anatomical precision, the particular drape of the skin around the ears, the exact curvature of the trunk, the specific way the forefoot falls, that you can identify the subspecies. There are hippos, clearly depicted in water that surrounded the artists on every side, painted from the perspective of people for whom hippos were not exotic zoo animals, but everyday neighbors. There are cattle, thousands of cattle in vast herds, tended by herders who painted themselves alongside their animals, with an intimacy that tells you everything about how central these animals were to their identity and self-understanding. Each painting shows individual animals with distinct coat patterns, distinct horn shapes, distinctive markings that identify them as specific individuals. These are not symbolic cows, but portraits made by people who knew their animals as a shepherd knows each member of a flock, as a parent knows each child. There are crocodiles. There are fish painted in the act of being caught, showing specific species, catfish, tilapia, perch, that can still be identified by the way the artists rendered their distinctive body shapes and scale patterns. There are scenes of swimming, people in water, diving, splashing, floating, painted by people for whom water was so abundant that swimming was leisure, not survival, recreation rather than the desperate act of crossing from one shore to another. There are scenes of dancing, of ceremony, of what appear to be musical instruments being played in social contexts that speak of communal celebration, of the kind of gathering that only happens when people have enough surplus to pause from work and simply be together. There are ritual scenes whose meaning is no longer fully decipherable. Figures with animal heads, scenes of transformation, images that suggest a rich, symbolic and spiritual life centered on the animals and the landscape around them. These are not the images of a population in survival mode. These are the images of a civilization at ease in its world. A civilization that had enough food, enough water, enough time, enough safety to stand at the edge of a lake in what is now the most inhospitable desert on earth, and make art with a care and skill and love that has survived 10,000 years and will survive 10,000 more. The art changes over time, and this is where it becomes truly extraordinary as a historical document, because the rock art record is not just a snapshot of the Green Sahara at its peak, but a continuous chronicle of the transformation from abundance to aridity, recorded in real time by the people who experienced that transformation. The earliest images, the ones that date from the very beginning of the African humid period or even earlier from the preceding dry period, show primarily wild animals, aurochs, the enormous wild ancestors of domestic cattle, Barbary sheep, which still survive in isolated Saharan mountain refuges today, antelopes in multiple species, large predators including lions and leopards and what appear to be hunting dogs. These are the images of hunter-gatherers, people who knew the animals as prey and competitor and neighbor, but not yet as livestock. Then the herders appear. Somewhere around 8,000 years ago, the rock art begins to show a transition. Humans are increasingly depicted not just hunting animals, but managing them, moving among them in ways that suggest herding rather than hunting. The animals change too. Some of them begin to look slightly different from their wild counterparts, with horn shapes that suggest the kind of selective pressure that comes from human management. And the cattle multiply. The cattle proliferate in the art until they dominate entire cliff faces, hundreds of animals in vast panoramas of pastoral abundance that celebrate the relationship between people and their herds with a richness and complexity that leaves no doubt about how central this relationship had become to the culture. Then the landscape begins to subtly shift in the images themselves. The water scenes become less frequent. The hippo disappears. The crocodile disappears. The fish disappear. The cattle are still there, but they are increasingly depicted being driven through landscapes that the artists are subtly showing as harder, more demanding, less lush. New animals appear. Horses, probably introduced from the north, used for transport. Later, camels, the animal of the desert, the animal that couldn't have survived in the green Sahara at its peak, but that becomes essential as the land dries. The camel's appearance in the rock art is, in retrospect, the clearest possible signal that the world was changing in a direction from which there was no return. The camel doesn't paint itself. The people painted it because it had become necessary. And you don't need a camel when there's a lake outside your door. The art continues even into the historic period, into the time of the Roman Empire, into the era when North Africa was part of the classical Mediterranean world. But the subjects are different. The abundance is gone from the images. What remains is a record of people adapting, as humans always adapt, to the world as it is rather than the world as it was. The rock art of the Tassilin Ayr is the Green Sahara's autobiography, written by the people who loved it, documenting both its splendor and its disappearance, preserving in pigment and stone the memory of a world that the desert has now covered entirely, except where the rock walls still stand, painted with the animals that once walked beside them. Here is what I find most astonishing about the Green Sahara, the thing that stops me cold every time I sit with it. And it isn't the size of the lakes, or the richness of the fauna, or the beauty of the rock art. What stops me is this. It wasn't just a different climate. It was a different world. A world that produced human civilizations, human cultures, human stories, and then swallowed them almost without a trace. The people who lived in the Green Sahara weren't primitive survivors scratching out an existence at the margins of habitability. They were sophisticated, socially complex, culturally rich communities that had found in the Sahara's abundance everything they needed to flourish. Consider what we know about what their daily life looked like. They had access to protein in extraordinary abundance, fish from the lakes and rivers, game animals from the grasslands, dairy products from their herds. Studies of the skeletal remains from sites like Gobero show people who were, by the standards of their time, remarkably healthy, well-nourished, showing fewer signs of the stress-related bone damage that characterizes populations living on the edge of subsistence, with statures that reflect adequate protein intake across the full span of childhood development. These were people who had enough to eat, consistently, year after year, generation after generation. They had art in the full sense, art made for aesthetic and spiritual reasons, art that required training and skill and intention, art maintained over generations in a living tradition that evolved and changed and responded to new circumstances while preserving continuities of style and subject that stretched back thousands of years. The rock art tradition of the Sahara is not casual or incidental. It is the product of specialists, of people who dedicated significant time and energy to learning the craft and practicing it, which means it is the product of a society that could afford to have specialists. A society with enough surplus production that some people could spend their days making art rather than food. That is not a marginal society. That is a developed society. They had ceremony, elaborate mortuary rituals, careful attention to the positioning of the dead, grave goods that speak to beliefs about what happens after death, and about the social bonds that survive it. The burials at Gobero are not simple holes in the ground. They are prepared spaces, oriented deliberately, furnished with objects chosen for their relationship to the person being buried. Ostrich eggshell beads, the manufacturing of which requires hours of careful work. Hippo ivory jewelry, the acquisition and working of which required both the capacity to hunt large and dangerous animals and the skills to shape the ivory into decorative objects. Animal bones, sometimes whole skulls, placed in graves in ways that suggest symbolic meaning rather than casual disposal. They had trade networks stretching from the Mediterranean to sub-Saharan Africa, evidenced by materials found at Saharan sites that could only have come from hundreds of miles away. Shells from coastal waters, obsidian from volcanic sources, pigments of specific mineral compositions found only in distant regions. Trade networks don't maintain themselves. They require a level of social infrastructure, reliable routes, trusted intermediaries, shared conventions for exchange, surplus production to offer in trade. That speaks to a level of social organization far beyond what a group of desperate survivors cobbling together an existence in a marginal environment would be capable of. The trade networks of the Green Sahara connected communities across a continent and maintained those connections for thousands of years. And most importantly, they had time. Not just time in the sense of years and decades, but time in the sense of mental space, the cognitive leisure that comes from not spending every waking moment in the exhausting business of bare survival. When you have enough food and enough water and a community organized enough to share the labor of providing them, you get something precious and rare. Time to think, time to create, time to observe the world around you with the curiosity of someone who isn't desperate, who can afford to wonder. Time to sit at the edge of a lake and watch the hippos and paint them on the rock wall. Time to develop rituals for the dead that honor the weight of loss. Time to teach children not just where the food is, but what the world means. This is the environment that produces culture. This is the environment that produces the accumulation of knowledge and practice and symbol that we call civilization. The population of the Green Sahara at its peak is difficult to estimate with precision, but the evidence, the density of sites, the evidence of sustained occupation across thousands of years, the scale of the cultural production, suggests numbers in the millions. Millions of people living in one of the richest environments in Africa, developing the cultural and social tools that would become the inheritance of every civilization that came after them. They are not a footnote to African history. They are one of its central chapters. And when the Sahara dried and their world disappeared, it didn't just displace a population. It ended a civilization that had been building for 6,000 years. Consider the timing, because the timing is everything. The African humid period ended in most of the Sahara somewhere between 5,000 and 3,000 years ago, roughly 3,000 to 1,000 BCE. As the monsoon. Disclaimer. This video contains fictional and / or AI-assisted elements created for artistic and entertainment purposes. It does not aim to mislead viewers or present real-world events as factual documentation. As the monsoon retreated south, as the lakes shrank and the rivers diminished and the grasslands gave way to sand, the people who had built their lives in the Green Sahara did what all displaced people do. They moved. They followed the water. They went south into the wetter lands of sub-Saharan Africa, carrying with them the cattle-herding traditions and the social structures that would eventually give rise to the great pastoral cultures of East and West Africa. They went north toward the Mediterranean, contributing to the cultural complexity of the North African and eventually the Mediterranean world. And they went east, toward the Nile. Egypt, the Egypt of the pharaohs, the pyramids, the hieroglyphs, the most famous civilization in the ancient world, didn't emerge from nowhere. Nothing does. Everything has a before. And the before of ancient Egypt includes, as one of its most significant chapters, the story of what happened when the dying green Sahara pushed its people eastward into the Nile Valley. The Nile Valley became the Great Refuge. It was the last major reliable source of water in northeastern Africa, and people flooded into it from the west, from the drying Sahara, carrying the accumulated knowledge and cultural practices of thousands of years of life in one of the richest environments that Africa has ever supported. They brought cattle herding, the management of domesticated animals practiced in the Green Sahara perhaps earlier than anywhere else on Earth. A technology that was not just economically valuable but socially organizing, creating the hierarchies and the collective practices that form the skeleton of a complex society. They brought artistic traditions, the pictorial conventions developed in the Saharan rock art over thousands of years, conventions that show up with sometimes startling directness in the earliest Egyptian art, in the way animals are depicted, in the way boats and people and sacred scenes are organized on cave walls and then on the walls of tombs. They brought social structures developed over millennia of managing life around the great Saharan lakes. Structures capable of organizing large populations around shared resources in ways that would be immediately applicable to the management of the Nile flood and the agricultural abundance it produced. They brought the accumulated cultural capital of the Green Sahara, and they brought it directly to the banks of a river that would prove to be the foundation of one of history's greatest civilizations. The evidence for this connection is growing more detailed and more compelling with each passing decade of archaeological and genetic research. The sites at Nabta Playa in the Egyptian Sahara tell a particularly striking story. Nabta Playa is a dry lake basin in the western desert of Egypt that was occupied repeatedly by people from before the African humid period through to its end. And what they left behind includes not just the expected tools and food remains, but a ceremonial complex, a circle of standing stones, thought to be one of the earliest astronomical alignments in the world, predating Stonehenge by more than 1,000 years. These were not simple people. These were people with sophisticated astronomical knowledge, with the capacity for collective labor sufficient to move and erect large stones, with a symbolic system complex enough to encode astronomical information in a permanent monument. And when the lake at Nabta Playa dried for the last time, sometime around 5,500 years ago, the people who had built that monument moved east, to the Nile, to Egypt. Archaeologist Savino de Lernia, who has spent decades studying the Libyan Sahara, has argued that the connection between the dying Green Sahara and the rise of Egyptian civilization is not coincidental, but causal. The population pressure created by the drying desert, the concentration of people and cultural knowledge in the Nile Valley, may have been one of the critical catalysts that triggered the rapid development of Egyptian civilization in the 4th millennium BCE. The emergence of writing, of monumental architecture, of the complex religious and administrative systems that characterize dynastic Egypt, all of these occurred in a period that coincides almost perfectly with the final drying of the Sahara and the culminating flood of Western refugees into the Nile Valley. The Green Sahara's death may have been ancient Egypt's birth. This doesn't diminish Egypt. It contextualizes it. It places it in the longer story of African human history. A story that begins not on the banks of the Nile, but in the heart of what is now desert, in communities whose names we will never know, and whose languages we cannot speak, who painted hippos on the walls of sandstone towers, and buried their children with love in the sediment of lakes that no longer exist. Let's talk about how we know all of this, because the science behind the Green Sahara is as extraordinary as the story itself. And understanding it reveals something important about the ingenuity that humans bring to the task of reading the past. The science of the Green Sahara is fundamentally the science of proxies, of things that stand in for direct evidence, of clues that require interpretation, of data that speaks obliquely about conditions no human alive today has experienced. After the 1981 radar images revealed the buried river systems of the Eastern Sahara, geologists and climate scientists began drilling core samples from the sediments of ancient lake basins, places where the lake had dried, but where the sediments left behind were still preserved. These sediment cores are time capsules. Each layer of sediment represents a period of time, and the composition of each layer, what minerals it contains, what biological remains it preserves, what isotopes of carbon and oxygen are present, tells you about the environmental conditions that prevailed when that layer was deposited. The process is painstaking and requires expertise from multiple disciplines: geochemistry, palynology, paleontology, isotope physics, and more. But the information it yields is extraordinary. From a core drilled in the dried basin of a former Saharan lake, scientists can tell you not just that the lake existed, but approximately how deep it was, how warm the water was, whether it was fresh or saline, what plants surrounded it, what animals lived in and around it, and, with remarkable precision, when it existed and when it dried up. The precision comes primarily from radiocarbon dating, which measures the ratio of radioactive carbon 14 to stable carbon 12 in organic materials to determine how long ago a living organism died. Radiocarbon dating is accurate to within a few decades for samples up to about 50,000 years old, which means scientists can construct timelines of lake existence and disappearance in the Sahara with a resolution that would have seemed impossible a generation ago. But the sediment cores are just one tool in an increasingly sophisticated arsenal. Remote sensing technology has advanced enormously since 1981, and modern satellite radar systems can produce images of the subsurface landscape with a resolution and coverage that the Space Shuttle's instruments could only dream of. The European Space Agency's Copernicus satellite program, NASA's various radar and multispectral sensors, and increasingly sophisticated commercial satellite operators are producing a continuous stream of data about the Sahara's subsurface geology that scientists are only beginning to fully process and interpret. Each new dataset adds detail and resolution to the map of the buried Green Sahara, revealing smaller watercourses, identifying additional lake basins, tracing the connections between hydrological systems that were once part of a single continent-spanning network. Ground-penetrating radar, deployed by research teams working in the desert on foot or by vehicle, can reveal the shallow subsurface structure of specific sites at a centimeter-scale resolution that satellites can't achieve. Identifying buried archaeological features, tracing ancient shorelines, locating the boundaries of former lake beds with precision sufficient to guide excavation. Drone technology is increasingly being used to survey archaeological sites with an aerial perspective that reveals patterns invisible from ground level, identifying concentrations of artifacts, tracing the outlines of ancient structures, and documenting the spatial organization of settlements that were occupied for generations before being abandoned to the advancing sand. The synthesis of all these data streams, the satellite radar, the sediment cores, the ancient DNA, the fossil pollen, the isotope geochemistry, the archaeological survey, is producing a picture of the Green Sahara that is, in its detail and its coherence, one of the most remarkable achievements of modern interdisciplinary science. Every year, the picture grows sharper. New drilling expeditions, new satellite passes, new analytical techniques, all of them adding detail and nuance to a story that began with Killian looking down from his cockpit in 1933 and not quite believing what he saw. Killian was right. The science is only now catching up to the magnitude of what he glimpsed. The pollen record is particularly revealing, and I want to spend some time on it because it illustrates beautifully the way that science extracts information from the world that the world never intended to give up. Pollen grains are almost indestructible. They are produced in enormous quantities. A single tree can release millions of pollen grains in a single season. And they have a chemical composition called sporopollenin that resists decay under the right conditions for hundreds of thousands of years. Each plant species produces pollen grains with a unique shape, a distinctive surface texture, and structural pattern that allows specialists to identify the species from the grain alone, long after every other trace of that plant has disappeared. The leaf is gone. The wood is gone. The flower is gone. The root is gone. But the pollen, settled into the sediment at the bottom of a lake and buried under 10,000 years of subsequent deposition, is still identifiable under a microscope as specifically and definitively as if the plant itself were standing in front of you. When pollen grains fall into a lake, they sink to the bottom and are incorporated into the sediment, where they are preserved in the low oxygen environment of the lake floor for geological timescales. This preservation is so consistent and so reliable that palynologists, scientists who study pollen, can reconstruct the vegetation of an area in meticulous detail from the pollen assemblage in a sediment core. The technique is called pollen analysis, and in the context of the Green Sahara, it has produced results that are nothing short of revolutionary. The pollen from Green Sahara sediments tells a story of abundance that is almost hard to process, because the contrast with the modern Sahara is so extreme. Modern Central Saharan sediments contain almost no pollen. The desert is simply too dry and too sparse to produce meaningful quantities of pollen, and such grains as are deposited are typically long-distance transport from far-away vegetation zones rather than local plants. The contrast with the Green Sahara pollen record is absolute. The Green Sahara samples overflow with local pollen from dozens of species, documenting a landscape covered with vegetation from ground level to canopy. There are grasses, vast quantities of grass pollen, indicating the savanna and grassland environments that covered much of the region, grasses that were the foundation of the herbivore food chain that supported the hippos and elephants and antelopes, whose bones are scattered through the same sediments. There are tree pollens, olive trees in the north, acacia, and other typical African savanna trees in the central Sahara. Wild fig trees whose presence indicates permanent water nearby. There are aquatic plants, water lilies and reeds and sedges, scattered through lake sediments in quantities that tell you the lakes were large and stable, and surrounded by dense wetland vegetation, the kind of reedbed habitat that provides nesting and feeding grounds for enormous communities of waterbirds. There are even forest trees in some of the higher elevation areas of the Sahara, suggesting that the mountains that poke above the desert floor, the Tibesti in Chad, the Hoggar in Algeria, the Tassili Naja, were covered in woodland during the Green Sahara period in ways that seem impossible given their current aridity. The Tibesti today receives perhaps an inch of rain a year. 12,000 years ago, it was forested. The pollen record also allows scientists to track the timing of the Green Sahara's beginning and end with remarkable precision. By dating the sediment layers in which the pollen composition shifts from desert to grassland or from grassland to forest, researchers can pinpoint exactly when the transition occurred in each region, building up a detailed map of how the African humid period expanded and contracted over time. The data shows that the Green Sahara didn't begin everywhere at once. It moved. The northern extent of the monsoon system expanded progressively northward as the orbital forcing strengthened, greening the central Sahara first, then the northern Sahara, reaching its maximum northward extent somewhere around 9 to 10,000 years ago, before beginning its slow retreat. The pollen record captures this migration in the sequential timing of the vegetation transitions across different latitudes. The sediment cores also contain the bones of animals, the tiny, perfectly preserved bones of fish, of frogs, of small mammals, of aquatic invertebrates, that tell the same story from a zoological perspective. These are not isolated fossils. They are ecological assemblages. Communities of species preserved in the same sediment layers, telling you not just that individual species existed, but that entire ecosystems were functioning, that the food webs were intact, that the biological communities were complete and productive. The bones, the pollen, the isotopes, the radar images. Each one is a fragment of a picture that is growing, year by year, more complete, more detailed, more astonishing. Let me take you somewhere specific, because the abstract history of climate change and ecosystem transformation becomes real in a different way when you stand in a particular place and understand what it once was. The Wadi al-Hayar in the Fezzan region of southwestern Libya is called in Arabic the Valley of Life. The name is heartbreaking because the valley is not alive today in any sense that would make the name feel earned. It's a dry valley in one of the driest parts of the Sahara, a geological feature carved by water that no longer runs, a scar in the landscape that speaks of force and movement, and now vanished abundance. The Fezzan region is not much visited. It is remote even by Saharan standards. Days of driving on unpaved tracks from the nearest major city, through landscapes that test even well-equipped vehicles. The people who live there today, mostly Tuareg and Tubu communities with ancient relationships to the desert, know the landscape with the intimacy of generations, and their knowledge includes an awareness of what is underfoot. They know where the dry wadis are. They know which rock formations were shaped by water. They know by the texture of the soil and the depth of certain depressions, where water once collected and might collect again after a rare rain. Their ancestors watched the water leave. Their oral traditions preserve the memory of what was here. During the African humid period, the Wadi al-Hayar was a river, a major river, permanent and deep and lined with trees and dense with animal life, flowing through a landscape that received enough rain to support continuous vegetation from the Mediterranean coast to the lakes of the central Sahara. Along its ancient banks, over decades of archaeological work conducted primarily by Italian and Libyan researchers working in collaboration, scientists have found everything that a thriving human community of the Green Sahara would have left behind. Stone tools from multiple time periods, spanning the entirety of the African humid period, show continuous or near-continuous human occupation of the valley from its beginning to its end. The earliest tools are relatively simple, handheld scrapers and choppers in the mode of the earlier Stone Age, tools designed for the immediate tasks of butchery and plant processing. Later tools reflect increasing technological sophistication, carefully shaped points, microlithic inserts for composite tools, grinding stones for processing plant foods. The progression tells a story of human communities becoming more established, more sedentary, more invested in the specific landscape around them over thousands of years. People were not just passing through the Wadi al-Hayar, they were building lives there. The bones of aurochs, the wild ancestor of domestic cattle, an animal that stood 6 feet at the shoulder and weighed as much as a modern sedan, an animal that required an abundance of rich grassland to sustain its enormous body, are scattered through dozens of the valley's sites. The aurochs is extinct now, hunted to death in Europe and North Africa as the combined pressures of climate change and human predation made its already difficult life impossible. But in the Green Sahara, the aurochs was not extinct. It was abundant. It was the great prey animal of the Saharan savanna, and the people who hunted it left behind the bones of hundreds of individuals at dozens of sites in the valley, a record of hunting success that speaks to the extraordinary productivity of the grasslands that fed these animals. Fish bones. Always, everywhere, the fish bones. The people of the Green Sahara ate fish in staggering quantities, and the remains of their meals are preserved in sediments along what were once riverbanks and lake shores, layer upon layer of discarded bones, a record of abundance made by people who caught more than they needed and could afford to be selective, who left behind the less desirable parts and kept the best, who had the luxury of preference rather than desperation. The fish bones in the Wadi al-Hayar include species that today are found hundreds of miles to the south in the permanent rivers and lakes of sub-Saharan Africa. Nile perch, tilapia, catfish in the genus Clarius that I'll tell you more about later. Their presence here tells you that this was permanent, deep, productive water, connected to the larger Saharan hydrological network, part of a system of rivers and lakes that stretched across the continent, the Valley of Life. The name was given by someone who knew the evidence, someone who had stood in the dry wadi and looked at the bones and the tools and the grinding stones and understood, looking backward through 10,000 years of geological change, that life had been here, rich and abundant and persistent, and that the valley deserved to keep its name even after the life was gone. Because the name is not just a description of the past, it is a promise that the evidence makes on behalf of the land. This was once alive, and it was alive here, and we remember. I want to talk about the children of the Green Sahara because this is the part that haunts me the most. When Paul Sereno's team excavated the burial site at Gobero in 2008, among the hundreds of skeletons they found were children. Children buried with the same care as adults, sometimes more care, as if the loss of a child was a wound that demanded the most elaborate response the community could offer. Children buried with jewelry, beads of ostrich eggshell, each bead individually shaped and pierced, representing hours of careful work, placed around the neck or wrist of a child who may never have lived to see their 5th birthday. Small pendants, objects chosen specifically for this particular child and placed in the grave with deliberate intention, with the care of someone saying, "This mattered. This person mattered. This loss matters." Children buried with the bones of animals, the skulls of young animals placed near the children's heads, perhaps meals for the journey they were about to take, perhaps companions, perhaps symbols of a relationship between these children and the animals that surrounded their world from their first conscious moments. Children buried in postures that suggest they were being put to sleep rather than committed to the earth. Arms folded, legs gently flexed, heads inclined at the angle of rest rather than of ceremony. Bodies arranged with a gentleness that speaks across 9,000 years with unmistakable clarity. Someone lifted these children into their graves with care. Someone arranged their arms and legs and heads not for the living to see, but for the dead to be at peace in. Someone stood at the edge of a grave in the heat of a Saharan afternoon and spent time, precious time, making sure that a child was comfortable in the ground. And among those children, the burial I mentioned earlier, the woman with 2 children, one on each side of her, their arms intertwined in an embrace that has lasted 9 millennia, preserved in the dry sediments of a lake that was already a memory by the time the first Egyptian pharaoh was born. When the scientists uncovered this burial, the team stopped working. There are moments in archaeology when you put down your brushes and simply look, because what you're looking at is not evidence. It's a human being. It's three human beings, arranged in a posture of love, preserved by accident and found by strangers 9,000 years after the people who made that arrangement were themselves dead and gone and forgotten by every living person on Earth. You look at the position of the arms, the way the two smaller skeletons are nestled against the larger one, the way the larger skeleton seems to lean toward them, the way the combined posture creates a closed, complete, self-sufficient unit of care. And, without any scientific interpretation needed, exactly what you are looking at. These were people who felt at home in the world they inhabited. They were people who expected their world to continue. They were people who built cemeteries, not just burial sites, but cemeteries, returned to over generations where the community's dead were gathered and remembered in a fixed place that gave the living a physical location for the emotion of grief. A community in crisis doesn't build cemeteries. A community in crisis buries its dead wherever it happens to be when death occurs, and then moves on, because the living can't afford to be attached to the dead. A community that builds a cemetery is a community that plans to stay. A community that returns to the same cemetery for 5,000 years is a community that did stay, that rooted itself in a landscape so completely that its dead became part of that landscape, that the site of burial became as much a part of home as the site of the lake, or the site of the fire, or the site of the grinding stone. Gobero was their home. The lake was their lake. The fish were their fish. The cattle were their cattle. The children buried with ostrich eggshell beads and the bones of young animals were their children. And the green Sahara, the world that made all of this possible, was their world, as surely and as completely as any world has ever belonged to any people. And the green Sahara died. The death of the green Sahara is in some ways the most important part of the story, and also the most disturbing, because it wasn't a catastrophe in the conventional sense. There was no asteroid, no supervolcano, no sudden violent event that ended the world of the green Sahara in a day or a decade. No enemy army, no disease, no famine in the sudden, acute sense of a harvest failure. Instead, there was something slower and, in its own way, more terrifying. A tipping point, a threshold crossed, a balance undone. A system that had been stable for thousands of years that reached the edge of its stability and fell off. For thousands of years, as the orbital changes slowly reversed, the Sahara remained green. The monsoon gradually weakened, but the land absorbed the change with a resilience that must have felt, to the people living through it, like permanence. The vegetation held on. The lakes shrank but didn't disappear. The rivers ran lower but continued to flow. Life adapted. People adapted. And then, somewhere between 5,000 and 4,000 years ago, in most of the Sahara, the balance tipped. Not everywhere at once. The timing varied by region, with some areas holding on longer than others, with some elevated refugia maintaining wetter conditions long after the surrounding lowlands had become desert. But region by region, decade by decade, the tipping point arrived. The mechanism is now understood in broad strokes, and it involves a feedback loop that is as elegant as it is devastating. Vegetation plays a crucial role in maintaining rainfall in arid and semi-arid regions. Plants release water vapor through transpiration, contributing to local cloud formation. A large, well-vegetated landscape transpires enormous quantities of water into the atmosphere. Some estimates suggest that the Amazon rainforest generates as much as half of its own rainfall through this mechanism, And the Green Sahara, covered in dense savanna and gallery forests and wetland vegetation, was almost certainly playing a similar role in its own water cycle. Plants keep soil in place, preventing it from blowing away as dust. And plants darken the land surface. A vegetated landscape absorbs more solar energy than bare sand, which reflects most incoming sunlight back into space. The absorbed energy drives convection, which drives cloud formation, which drives rain. Plants make rain. And when you remove plants, you reduce rain. This is the heart of the feedback loop that destroyed the Green Sahara. As the orbital forcing weakened and the monsoon began its slow retreat south, some areas of the Sahara received slightly less rain. With slightly less rain, vegetation in those areas became slightly less dense. With slightly less dense vegetation, slightly more bare soil was exposed. Bare soil reflected more sunlight than vegetated soil, which reduced the convective heating that drove cloud formation over the land surface. Less cloud formation meant less rain. Less rain meant the vegetation declined further. Declining vegetation meant more bare soil. More bare soil meant less convection. Less convection meant less rain. The Sahara was eating itself, consuming its own life support in a spiral that, once started, was very difficult to reverse. Each step in the process was small. Each individual change in rainfall or vegetation was barely perceptible over a human lifetime. But the direction was always the same, and the direction was toward desert. For thousands of years, the process was slow enough that human and animal communities could adapt, could shift their grazing ranges and their seasonal movements, could follow the retreating water to the places where it still gathered. The lakes shrank year by year, their shorelines retreating, their depth decreasing, their productivity declining, but still there. The rivers ran lower in the dry season and sometimes failed to rise as high in the wet season, but still flowed. And then, in some regions, something happened that the slow deterioration hadn't prepared anyone for. The rate of change accelerated. The tipping point was crossed. And what had been a gradual drying became, in geological terms, a crash. The speed of the collapse, when it finally came, surprised scientists when they first began to study the detailed record in high-resolution sediment cores. For thousands of years, the Sahara had been gradually, almost imperceptibly drying, losing a little moisture each century, retreating from the extreme northern extent of its green phase, its lakes shrinking by meters rather than by the hundreds of meters they would eventually lose. The change was real but slow enough that human communities could adapt, could shift their grazing routes, could move to higher elevations where the orographic rainfall from mountains maintained vegetation longer. If you had been alive at any point during the first 3,000 years of the drying, you might not have noticed anything definitive within your lifetime. You might have told your grandchildren that the wet seasons seemed a little shorter than they used to be, that the lake where your grandfather fished had pulled back from the shore where he used to stand, that the grass in certain valleys wasn't as thick as it was in the stories of the old people. You wouldn't have said, "The world is ending." And then, in some regions, the transition from grassland to desert happened in what the geological record suggests was not centuries, but decades. In some interpretations, perhaps less. Decades. In the context of a climate system stable for millennia, this was essentially instantaneous. The lakes didn't slowly drain over centuries, giving the communities around them time to adapt. They crashed. Lake Megachad, which at its peak covered 400,000 square kilometers, retreated within a few thousand years to a ghost of itself. The rivers dried up in sequence. First, their flows diminished. Then they became seasonal. Then they became intermittent, running only in the rainy season and drying out completely in the dry. Then the rains themselves diminished to the point where even the seasonal flow stopped. Then the riverbeds went dry and the sand blew in, and the dunes marched over the channels, and the desert consumed the rivers from above, while the sun consumed them from below, leaving nothing but the buried rock channels that NASA's radar would reveal 5,000 years later. The animals died or moved first, because animals have no agency in the face of drought, other than to move toward water. The hippos would have been among the last to leave the central Sahara, because they need large bodies of standing water that would have persisted longer than the surrounding vegetation. But as the lakes shrank below the minimum depth that hippos require, as the water became too shallow to submerge in, too warm to thermoregulate in, too small to support the social groups that hippos require, they died or left for the south, for the permanent rivers of sub-Saharan Africa where their descendants still live today. The crocodiles were stranded in isolated pools in the mountains, where some of them survive still. The elephants moved south. The giraffes, with their ability to browse the tops of trees and reach water sources that shorter animals couldn't access, may have lasted longer than most, but they too were eventually gone, following the retreating vegetation to the wetter lands to the south. The people moved. But the movement was not always in time and not always successful, and the evidence from some green Saharan sites suggests that the collapse was not just ecologically catastrophic, but demographically so. That communities that had flourished for thousands of years declined rapidly as their resource base collapsed, that some groups that had built their identities entirely around the specific ecology of the Green Sahara, around the management of its particular herds, the exploitation of its particular fish and game, the navigation of its particular lakes and rivers, found themselves ill-equipped for the very different demands of the environments they moved into. The rock art record tells us this. The later paintings show not the abundance of the early Green Sahara, but the management of scarcity, the careful herding of cattle through landscapes that are clearly drier, clearly more demanding. And then the art becomes sparser as the people who made it disperse, as the communities that sustained the tradition break apart under the pressure of displacement. The autobiography of the Green Sahara ends, not with a dramatic final image, but with increasing silence, increasingly empty walls, increasingly ancient dates on the last paintings, before the record stops entirely and the desert takes over. Let me tell you about the Garamantes, because they are perhaps the most poignant illustration of what it means to live in the aftermath of the Green Sahara, to build a civilization on the inheritance of a wetter world, to be, in the most literal sense, living on borrowed time from a geological past that has no intention of returning. The Garamantes were an ancient Berber people who built a remarkable civilization in the Fezzan region of southwestern Libya, in the very heart of what had been Green Saharan territory, beginning around 900 BCE and lasting until roughly 700 CE, a span of nearly 2,000 years. At their peak, they controlled a major trans-Saharan trade route that connected sub-Saharan Africa to the Mediterranean world, carrying gold and ivory and enslaved people northward, and salt and manufactured goods southward. They maintained a capital city called Garama that classical authors described with evident respect. They engaged in agriculture, metalworking, and the production of luxury goods that found their way to Rome. They built tombs and temples and granaries, and all the physical infrastructure of a civilization that intended to be permanent. And they built the foggaras. The foggaras are thousands of kilometers of hand-dug underground tunnels, excavated through rock and sediment at a slight downward angle designed to intercept the water table and channel water by gravity to the surface, where it irrigated Garamantian fields in a landscape that received virtually no useful rainfall. Building them required extraordinary engineering knowledge. The tunnels had to be dug at precisely the right angle, steep enough to move water, but not so steep that the flow caused erosion and collapse of the tunnel walls. And they had to intersect the water table at exactly the right depth. Too shallow, and they'd be dry. Too deep, and the water pressure would require reinforcement that the available technology couldn't provide. Thousands of vertical shafts were dug from the surface down to the tunnel level for maintenance access, and these shafts, spaced at intervals of 20 to 50 meters along the length of each foggara, can still be seen from the air as lines of dots across the Fezzan landscape, visible in satellite images, as distinctive and as regular as the stitching on a garment. The foggaras were not just impressive engineering. They were the entire basis of Garamantian civilization. Without them, the Fezzan couldn't support the population density needed to sustain a trade empire. Without them, there was no agriculture, and without agriculture, there was no city, and without a city, there was no civilization in the recognizable sense. The Garamantes built their entire world on the premise that the water table would remain accessible, that the investment of labor in tunneling would produce a reliable return in water that could be diverted to their fields. But here's the thing about the water the foggaras tapped. It wasn't modern rainwater. There is very little modern rainwater in the Fezzan. What the foggaras intercepted was fossil water, ancient water that had soaked into the aquifers during the African humid period, during the Green Sahara, and had been sitting in the rock ever since. The water that the Garamantes drank, that they irrigated their wheat and barley with, that they used to water their livestock and supply their city. That water fell as rain between 7,000 and 5,000 years ago, in a world that no longer existed above the surface. The Garamantes were, in a real sense, drinking the rain of the Green Sahara. Every field they irrigated, every cup they drank, came ultimately from rain that had fallen thousands of years before they were born, in a world that no one alive in Garamantian times had ever seen or could have imagined. Their civilization was built on this finite inheritance. And when the water dropped too deep to reach, when the water table fell below the level their technology could access, depleted by centuries of extraction at a rate far exceeding natural recharge in a desert that received almost no rain, the Garamantian civilization declined. They dug their tunnels deeper. They extended their foggara systems further into areas of higher water table. For centuries, they innovated their way around the declining water. But eventually, the innovation ran out. The water was gone. Not all of it. Deep aquifers in the Fezzan still hold Green Sahara water today. But the portion accessible to a pre-industrial civilization, with only hand tools and gravity, had been exhausted. The inheritance of the Green Sahara had been spent. And the Garamantes, who had built one of the ancient world's most remarkable civilizations on the foundation of that inheritance, slowly faded from history. They didn't disappear overnight. They dispersed, merged into other cultures, lost the infrastructure that made their civilization possible, became in the end a footnote in Roman geographical writing and a mystery in the Libyan desert. There is a scientific debate about the Green Sahara that goes to the heart of how climate systems work and how difficult they are to model accurately, even with the most sophisticated computers and comprehensive data. The debate is about the role of vegetation in creating and maintaining the Green Sahara, and it has been running for decades without full resolution, which tells you something about both the complexity of the question and the intellectual honesty of the scientists asking it. The issue starts with the climate models. When scientists run simulations of Earth's climate during the African humid period, using only the orbital forcing, using only the change in the distribution of solar energy driven by the known variations in Earth's orbit and axial tilt. The models produce a moister Sahara. The models predict more rainfall than today, yes. The models show a northward shift of the monsoon, yes. But the moist Sahara that the orbital forcing-only models produce is not as moist as the Sahara we know from the geological evidence actually was. The models underestimate the green Sahara. The models predict partial greenness, and the evidence shows us something more complete, something more total, something more like what we might call genuine transformation. Something amplified the real green Sahara beyond what orbital forcing alone can explain. The most widely accepted explanation is that the vegetation itself was the amplifier. When the first monsoon rains pushed north in response to orbital changes, they encouraged the growth of plants. Those plants, through transpiration and albedo effects, increased local rainfall beyond what the orbital forcing alone would have delivered. That additional rainfall encouraged more plant growth. More plant growth increased transpiration and reduced albedo further. More rainfall followed. The system spiraled upward into a state of greater lushness than the initial forcing could account for, driven by feedbacks between the vegetation and the atmosphere that amplified the orbital signal into something much larger. The green Sahara was, in part, its own creation. But if vegetation was the amplifier, what exactly was the vegetation doing to the atmosphere? This is where the debate gets interesting because there are multiple possible mechanisms, and scientists are still working out their relative contributions. The albedo feedback is probably the simplest. Vegetated land is darker than bare sand, absorbs more solar energy, heats up more, drives more convection, and creates more rainfall. This feedback is well established, and its contribution to the green Sahara is generally accepted. But there's also the moisture recycling feedback, which is subtler and potentially more powerful. When vegetation transpires water, that water enters the atmosphere as water vapor, which is then available to condense and fall as rainfall somewhere downwind. In a well-vegetated landscape, this recycling of water through vegetation can significantly increase the total amount of rainfall that falls, above and beyond what comes directly from ocean evaporation. The Amazon, as I mentioned, may generate up to half of its own rainfall through this mechanism. If the green Sahara worked similarly, and the scale of its vegetation would have been comparable, then the contribution of moisture recycling to green Saharan rainfall could have been enormous. And then there's the dust feedback, which operates in the opposite direction from albedo and moisture recycling. Vegetation holds soil in place. When vegetation is removed, soil is exposed to wind, and in the Sahara, exposed soil blows. The dust that comes from bare Saharan soil is one of the most significant inputs to the global atmosphere. Modern Saharan dust fertilizes the Amazon, crosses the Atlantic, and influences climate patterns across much of the northern hemisphere. But Saharan dust also reflects incoming solar radiation, reducing the heating of the land surface and potentially weakening the convective systems that drive monsoon rainfall. During the green Sahara, when vegetation covered much of the Sahara, this dust production would have been dramatically reduced, which means the atmosphere over the Sahara would have been cleaner, warmer, and better able to support the convective rainfall that maintained the monsoon. This is another feedback amplifying the green Sahara beyond what orbital forcing alone could explain. The science is complex and still developing, but the core insight is clear. The green Sahara didn't just respond to climate, it shaped climate, and when it died, it helped kill itself. Here is where the story of the green Sahara stops being ancient history and becomes a mirror held up to the present. The feedbacks that made the green Sahara possible and the feedbacks that destroyed it are not peculiarities of the Saharan climate system. They are fundamental properties of the Earth's climate everywhere, operating at all times, shaping the relationship between land and atmosphere on every continent. The vegetation rainfall feedback operates in the Amazon. It operates in the Sahel. It operates in the forests of Southeast Asia and the grasslands of Central Asia and the boreal forests of Siberia. Wherever there is vegetation and atmosphere in contact, the same basic mechanism is at work. Vegetation maintains and amplifies rainfall, and the loss of vegetation reduces and diminishes it. When forests are cut down, the transpiration that drove local rainfall is reduced. The land surface brightens, reflecting more solar energy into space rather than absorbing it to drive convection. Convection decreases. Cloud formation decreases. Rainfall decreases. With less rainfall, remaining vegetation is stressed. With stressed vegetation, transpiration decreases further. With decreased transpiration, rainfall decreases further. The spiral moves in the direction of drying, of desertification, of the loss of the conditions that made the land productive in the first place. This is not a theory, it is an observed phenomenon, documented in agricultural regions around the world where large-scale deforestation has been followed by measurable reductions in local rainfall. This is happening in the Amazon right now. The Brazilian Amazon is the largest tropical rainforest on Earth, and it generates its own rainfall. The forest transpires so much water, it creates what scientists call flying rivers, invisible flows of water vapor that move across the continent and fall as rain in the Andes and in the agricultural heartlands of southern Brazil, watering the farms that feed hundreds of millions of people. Deforestation in the Brazilian Amazon has reached the point where some scientists believe the forest is approaching its own tipping point. The moment at which the loss of transpiration reduces regional rainfall enough to stress the remaining forest, which reduces transpiration further, which reduces rainfall further, in a spiral that ends not in tropical forest, but in savanna. They call it Amazon dieback. It sounds abstract until you replace Amazon with green Sahara and tropical forest with grassland and lake ecosystem. And then it sounds like something that has already happened, in living human memory, to the richest landscape in Africa. The mechanism is the same. The physics is the same. The outcome, if the tipping point is crossed, would be the same. The Sahel provides an even more direct parallel. In the 1970s and 1980s, catastrophic drought struck the Sahel, causing widespread famine across a band of countries from Senegal to Ethiopia. Crops failed. Livestock died. Hundreds of thousands starved. Millions were displaced. The images of this crisis, the skeletal children, the dying animals, the cracked, bare earth, were among the defining images of humanitarian catastrophe in the late 20th century. The drought was initially attributed entirely to natural variability, but subsequent research conducted over decades showed it was partly caused by human-driven land degradation, by overgrazing and deforestation and poorly conceived agricultural practices that had already stressed the land, that had already reduced vegetation cover and begun the albedo rainfall vegetation spiral, moving in the wrong direction. When the natural drought arrived, as droughts always do eventually in a semi-arid climate, the land was already weakened, already partway down the spiral, and the combination of natural forcing and human degradation tipped it into something far more catastrophic than the natural forcing alone would have produced. The mechanism that killed the green Sahara is still killing things. It has never stopped. But the Sahel story also contains its counterpart, the remarkable recovery of some Sahelian landscapes since the catastrophic drought of the 1980s, driven not primarily by changes in rainfall, but by the deliberate restoration of vegetation through farmer-managed natural regeneration and the protection of trees on agricultural land. In Niger, where the drought was worst, satellite images show that tens of millions of hectares that were nearly bare in the 1980s are now substantially vegetated. Green where they were not green before, productive where they were barren, supporting populations that have doubled and tripled since the crisis. The vegetation came back because people stopped destroying it and started protecting it. And when the vegetation came back, rainfall increased. Not dramatically, not enough to recreate the green Sahara, but measurably, demonstrably enough to make a difference. The feedback can work in both directions. The question is, which direction we choose. There's a dimension to the green Sahara's legacy that is almost never discussed in popular accounts of the story, and it may be the most immediately consequential legacy of all. When the green Sahara was alive, when the monsoon rains fell year after year for thousands of years across an area the size of the United States, not all of that water ran off into the lakes and rivers. A significant portion soaked into the ground, percolating slowly downward through rock and sediment until it accumulated in vast underground reservoirs called aquifers. This is the water cycle working as it always works. Some rain becomes immediate runoff, some is absorbed by plants and returned to the atmosphere through transpiration, and some soaks deep enough to become groundwater. Under normal conditions in any reasonably moist climate, the rate of groundwater recharge roughly balances the rate of groundwater discharge. Water table levels fluctuate seasonally and with long-term climate trends, but in the long run, the system is approximately in balance. The green Sahara was not normal conditions. 6,000 years of dramatically elevated rainfall over an area spanning millions of square kilometers recharged the aquifers of North Africa to levels that they have not reached since and will not reach again without a new African humid period, which orbital mechanics tell us won't arrive for another 10,000 years or more. The Nubian sandstone aquifer system, which underlies parts of Egypt, Libya, Sudan, and Chad, is one of the largest freshwater aquifers in the world, containing an estimated 150,000 cubic kilometers of water. For perspective, that's roughly equivalent to the combined volume of the Baltic Sea and the North Sea. Scientists have measured the age of this water using isotopic methods, comparing the ratios of different isotopes of hydrogen and oxygen in the water to the ratios expected from rainfall in different climatic conditions and at different times. The results are unambiguous. The water in the deep Nubian aquifer fell as rain during the last African humid period. It is, in the most literal sense, green Sahara rainwater. It is between 4,000 and 10,000 years old. It is the rain of a world that no longer exists above the surface, preserved underground while the world above it was transformed beyond recognition. Countries in the region are pumping this water to the surface. Libya's Great Man-Made River Project, one of the largest engineering projects in human history, a network of pipelines nearly 4,000 kilometers long that pumps fossil water from aquifer wells in the Saharan interior to the populated coastal strip, is sustained entirely by the fossil water of the Green Sahara. The project was completed in stages between 1984 and 2010 and currently delivers about 2.5 million cubic meters of water per day to Libyan cities and farms. Without it, Libya could not support its current population. Egypt taps the Nubian aquifer through wells in the New Valley and other desert development projects. Saudi Arabia, to the east, has pumped its own fossil aquifers so aggressively that wheat production, once sustained by fossil water irrigation, has been dramatically curtailed because the water table has dropped below economically viable pumping depth. But these aquifers are not being recharged at any meaningful rate. The rain that would refill them hasn't fallen in the deep Sahara in meaningful quantities since the Green Sahara died 5,000 years ago. Current rainfall in the central and northern Sahara averages less than 1 inch per year, far below the rate of recharge needed to replace what is being pumped out. The water that took 6,000 years of wet climate to accumulate is being extracted in decades. We are spending an inheritance that took thousands of years to accumulate at a rate that will exhaust it in a generation or two. When this water is gone, and it will be gone because extraction is dramatically exceeding any possible recharge, there will be no getting it back on any timescale meaningful to human civilization. There will be no engineering solution. There will be no climate fix that restores the Nubian aquifer's deep reserves in 100 years or 1,000 years. The deep fossil aquifers of the Sahara are a one-time gift from the Green Sahara, and we are unwrapping it as fast as we possibly can. Every cup of water drawn from these aquifers is a cup of water that will never be replaced. We are, in a very real sense, still living in the Green Sahara's shadow, eating its food, drinking its rain, building our civilization on a foundation laid by a world that died 5,000 years ago. There is a discovery that keeps reshaping our understanding of the Green Sahara's significance, and it concerns one of the most important technologies in the entire history of human civilization: the domestication of cattle. For decades, the canonical story was relatively straightforward. Wild aurochs were domesticated somewhere in the Near East, in the Fertile Crescent, probably in what is now southern Turkey or northern Syria, roughly 10,000 years ago. And from that origin point, domestic cattle spread westward into Europe and southward into Africa. The story was clean. It fit the archaeological record as it was then understood, and it had the satisfying simplicity that science seeks and that human beings find compelling. Then the genetic evidence started arriving, and the story got complicated in the most interesting way. Analysis of the mitochondrial DNA of modern African cattle breeds, the traditional genetics of maternal lineage, revealed a pattern that didn't fit the simple diffusion from the Near East model. African cattle showed genetic signatures suggesting an independent contribution to the domestic cattle gene pool from African wild aurochs. Not just a single introduction from the Near East with subsequent adaptation to African conditions, but something more complex, something that suggested that African wild aurochs populations had participated as a separate, parallel source in the development of African domestic cattle. This was not what the conventional story predicted. This was, if true, a second independent domestication, or something very close to it. A parallel process occurring on a different continent, producing domestic cattle through a different history of human-animal interaction. And where were those African wild aurochs? In the Green Sahara. The rock art of the Tassili Naaja and the Libyan Sahara depicts aurochs from the very beginning of the Green Sahara period, and then, over thousands of years, shows a transition that looks remarkably like the process of domestication. The animals in the earliest art are clearly wild, enormous, powerful, painted with the respect and the careful observation that hunters give to dangerous and important prey. The representations are specific and accurate. The distinctive horn shape of the aurochs, the massive shoulder hump, the long-legged, fleet-bodied form that speaks of an animal adapted to running long distances on open savanna. But as the millennia pass and the art accumulates, something changes. The animals get slightly smaller. Their horns change shape in ways consistent with the artificial selection that comes with breeding under human management. The way humans are depicted in relation to the animals changes, from pursuit and confrontation to something more like management and care. The cattle multiply in the images until they are the dominant subject. their herds moving across the rock walls in panoramas of pastoral abundance. The implication is staggering. The Green Sahara may not have just been a hospitable environment that cattle herding moved into from the Near East. The Green Sahara may have been one of the places where cattle herding was invented, independently in parallel with the Near Eastern domestication, in a world of abundance and human-animal proximity that gave people the time and the motivation and the opportunity to attempt the extraordinarily complex process of domesticating a large, dangerous wild animal and maintaining that relationship across generations. If that's true, then the cattle herding cultures of sub-Saharan Africa, the Maasai, the Dinka, the Nuer, the Zulu, the Fulani, and dozens of others whose identities are inseparable from their relationship with cattle, trace their traditions not just to the Near East, but to the Green Sahara. The cattle that the herders of the Sahara drove south when their world dried out carried in their genetics and in the cultural traditions of their herders the memory of a world that the desert had swallowed. The cattle traditions of sub-Saharan Africa are, in this reading, the living inheritance of the Green Sahara, the continuation, in lands that the Saharan people fled to, of a way of life that began in the heart of what is now the world's largest hot desert. The Green Sahara didn't just support human civilization, it may have helped create some of its most enduring and widespread forms. There is a story about the Sahara that goes deeper into human prehistory than the Green Sahara we've been discussing, deeper than the Holocene, deeper than the last 10,000 years. And that connects the Sahara's changing climate to one of the deepest questions in the study of human origins. How did modern humans spread from Africa to the rest of the world? This is not a small question. The dispersal of our species from its African homeland to every corner of the globe is one of the defining events of the last 100,000 years of Earth history, and the roots and timing of that dispersal are still being actively debated and revised as new genetic and archaeological data comes in. The conventional model, established in the 1990s and refined in the early 2000s, focused on the Sinai Peninsula as the primary route by which early modern humans moved from Africa into Eurasia, a route sometimes called the Northern Dispersal, crossing the land bridge between Egypt and the Near East that has been alternately submerged and exposed depending on sea level. This route is real and it was certainly used. The evidence for human presence in the Levant dating back to at least 100,000 years ago is well established. But there is growing evidence from genetics, from archaeology, and from climate modelling that the Sinai was not the only route, and may not even have been the primary one for some dispersal events. Because there were Green Sahara periods before the most recent one, multiple times in the past 100,000 years. The science identifies at least 3 or 4 humid periods in the Sahara that were significant enough to create habitable conditions across much of the desert. The orbital configuration that drives the African humid period recurred, the monsoon pushed north, and the Sahara greened. Each of those green periods created the same kind of hospitable environment: the lakes, the rivers, the game, the vegetation, the reliable water and food supply that made human movement through the Sahara not just possible but, in the language of population ecology, easy. Easy means something specific in this context. It means that a group of humans moving northward through the Sahara during a humid period wouldn't have been a desperate, death march migration through hostile terrain. It would have been an expansion into a landscape well stocked with everything needed to survive and move: water, game, plants to eat, social infrastructure from animal communities that humans could exploit. These were not dangerous passages. They were opportunities. Groups of modern humans moved north through these green corridors during the humid periods, reaching the Mediterranean coast of North Africa, and from there potentially crossing into Europe and the Near East, not through the Sinai, but across the shorter sea crossings of the Mediterranean, or through the Strait of Gibraltar. The genetic evidence read with increasingly sophisticated tools, including ancient DNA, from human remains that are now being found in increasing numbers across North Africa and the Sahara, is beginning to reveal these movements. The genetic signatures of modern North African, Near Eastern, and Southern European populations contain ancestry components whose origins and timing align with these ancient Saharan dispersals in ways that cannot be explained by Near Eastern or European sources alone. There are African genetic signatures in European populations that predate the Neolithic agricultural dispersal that appear to represent direct contributions from people who moved through a green Sahara into Europe at some point in the deeper past. The Green Sahara was, in this reading, one of the great engines of human genetic and cultural diversity. Not just a place where people lived during the most recent humid period, although it was certainly that, but a corridor that repeatedly opened and closed, repeatedly allowing or blocking human movement between sub-Saharan Africa and the rest of the world, repeatedly creating the conditions for the genetic exchange and the cultural transmission that has shaped the human species over the course of its entire modern existence. Every time the Sahara greened, it became a bridge. Every time it dried, it became a barrier. And the rhythm of that alternation, 10,000 years of bridge, 10,000 years of barrier, again and again for hundreds of thousands of years, drove the genetic and cultural divergence and mixing of human populations in ways we are only now beginning to understand in their full complexity. There are scientists working in the Sahara right now who are trying to push the green world back into existence, not by waiting for orbital cycles to recur in 10,000 years, but by doing something audacious: planting trees. The Great Green Wall Initiative, launched by the African Union in 2007 and now supported by dozens of international organizations, hundreds of NGOs, and billions in pledged funding from governments around the world, aims to grow an 8,000-kilometer band of restored land, spanning the width of Africa from Senegal in the west to Djibouti in the east. A mosaic of restored landscapes, rewilded areas, reforested zones, and sustainably managed farmland that would form a living barrier against the southward advance of the Sahara. The name is slightly misleading. It was never, even in the original conception, a single continuous wall of trees. But the ambition it represents is not misleading at all. The ambition is to reverse, on a continental scale, the process of land degradation that has been accelerating since the end of the Green Sahara, and that has consumed tens of millions of hectares of productive African land in living memory. The challenges are enormous, and they are worth being honest about, because the history of large-scale tree planting initiatives in semi-arid regions is not uniformly encouraging. Planting trees in an environment that barely receives enough rainfall to sustain them is not the same as planting trees in a temperate forest, where rainfall is reliable and soil organic matter is abundant, and the tree's own root systems and litter production create conditions that make survival increasingly likely as a forest develops. In the Sahel, trees planted without appropriate species selection, without choosing species that are adapted to the specific rainfall regime and soil conditions of a given area, will die. Trees planted without the involvement of local communities in their maintenance will die when the NGOs and government agencies that planted them move on to other projects. Trees planted without water harvesting techniques that collect and concentrate the limited rainfall into the areas immediately surrounding the trees will die in the first serious dry season. Many trees planted in early Great Green Wall projects did die, and the failure of those projects produced a legitimate critique of the initiative that prompted a fundamental rethinking of how landscape restoration in the Sahel should be approached. The rethinking produced better approaches. In Niger in particular, and more broadly across the Sahel, a technique called farmer-managed natural regeneration has produced results that are, by almost any measure, extraordinary. The technique is simple in concept, if not always in execution. Instead of planting nursery-grown seedlings that have no prior relationship with the specific soil and moisture conditions of a given place, farmer-managed natural regeneration protects and nurtures the natural regrowth of indigenous trees and shrubs from root systems that survive the ground even after the above-ground vegetation has been cleared or grazed down to nothing. The roots are there. They have been there for years, decades, sometimes generations. They represent the accumulated investment of those plants in their specific location, the investment in root depth and spread that gives them access to the deeper moisture that surface-planted seedlings can't reach. Given protection from grazing and from people cutting branches for fuel wood, given a modest amount of initial care and management, these root systems can regenerate into productive trees in a few years. And once a few trees are established, the dynamic changes. The trees provide shade that reduces evaporation from the soil surface, their roots improve soil structure and moisture retention. Their litter adds organic matter that feeds the soil biology, that makes more water available to more plants, and the whole system bootstraps itself into greater productivity and resilience. In the Tigray region of northern Ethiopia, in parts of Niger, in Senegal and Mali and Burkina Faso, communities using farmer-managed natural regeneration and related techniques have restored millions of hectares of degraded land in the past 2 to 3 decades. Fields that had been bare sand or heavily degraded scrubland within living memory, within the lifetimes of people still farming them, have been transformed into productive agroforestry landscapes with dozens of tree species per hectare, with significantly improved soil fertility, with measurably greater and more reliable crop yields. The Great Green Wall is not the return of the Green Sahara. It is not Lake Megachad refilling, not the hippos coming back to the Sahara Desert. But it is something genuinely remarkable. Human communities working with the land rather than against it, beginning to reverse a process of degradation that has been running for 5,000 years. And the physics that made the Green Sahara work, the vegetation rainfall albedo feedbacks, are the same physics that will make the Great Green Wall's success compound over time if it is given the chance. Plant enough trees, restore enough soil, add enough transpiration to the local water cycle, and the rain, hesitant at first, will begin to return. Long before there was science, long before there were sediment cores or satellite radar or radiocarbon dating, there were stories. And some of those stories, I think, remember the Green Sahara. Not with the specificity of scientific data, not with the precision of a dated sediment layer or a sequenced genome, but with something that might be even more important in a different way. Emotional truth, the weight of cultural memory, the encoded awareness that the world has not always been as it is now, that it has been other, and that the otherness was real and was lost. The myths of the cultures that border the Sahara and that descend from the peoples who once lived within it are full of paradise lost, full of the memory of a time when abundance was ordinary and loss was exceptional rather than the other way around. Berber traditions from North Africa speak of a time when the desert was a garden, when the mountains ran with water, when the lands that are now sand supported forests and animals, and an abundance that no one living has ever seen. The Tuareg oral traditions, collected by researchers working in the Saharan interior over the past century, preserve in sometimes extraordinary detail the memory of specific landscapes. specific valleys, specific mountains, specific places where water once ran, that the geological record confirms as accurate. These are not vague myths of paradise. They are place-specific, landscape-specific memories of a Sahara that was different, that were accurate enough in their geographic references that they can be checked against the physical record and found to be, in their essential facts, correct. There are Egyptian religious and mythological traditions that scholars have connected with varying degrees of confidence to the transition from the Green Sahara to the desert. The Egyptian concept of Zep Tepi, the first time, a mythological golden age at the beginning of the world when the gods walked on earth and the natural order was in its perfect original state, has been interpreted by some scholars as a cultural memory of the African humid period, when the landscape of northeastern Africa was genuinely more abundant and more ordered than the world the historical Egyptians inhabited. The concept of the field of reeds, the Egyptian afterlife, is depicted in tomb paintings as a landscape of lush wetlands and abundant crops and flowing water, a landscape that bears a suspicious resemblance to what the Sahara actually looked like during the Green Sahara period, and very little resemblance to either the Egypt of the pharaohs or any other landscape the historical Egyptians would have had direct experience of. Perhaps the afterlife was, in part, the memory of a real landscape that the ancestors had inhabited and that had been encoded in the culture as the image of perfection. I want to be careful here. Myths are not historical records. They change over time, they accumulate layers of meaning, they serve purposes, social, political, religious, that have nothing to do with accurate historical memory. You can't read a myth as a newspaper, but the persistence across so many cultures around the Sahara of some version of the Paradise Lost narrative, some story of a time when the land was different, richer, more alive, more ordered, is striking enough to deserve serious attention. It is consistent with the idea that cultural memory can preserve, in encoded and transformed form, accurate information about environmental conditions that changed well before the historical period and long before writing was invented. The memory of the Green Sahara may not have been preserved in writing, in the precise and literal way that scientific knowledge is preserved, but it may have been preserved in something more durable than writing. The stories that communities tell about who they are and where they came from, and what the world was like before it became what it is now. I want to describe something that is difficult to put into words, but I want to try anyway, because I think it matters for how we understand the Green Sahara. Not just as a scientific fact or a historical curiosity, but as a human reality that connects to something deep in the way we relate to the places we call home. If you have ever stood in the Sahara, really stood in it, not at an oasis or at the edge of a tourist development, but in the middle of it, away from roads and people and all the comforting signs of human infrastructure, you know that it does something to time. The silence is not merely the absence of sound. It is a presence, a weight, a quality of stillness that seems to come from the land itself rather than from the lack of anything to disturb it. The rock is ancient in a way you feel in your body before your mind has processed it. The light is extraordinary, brutal and clarifying at noon, transcendent at dawn and dusk, when the angles are low and the rock glows in colors that seem too vivid to be real. Terracotta and gold and a deep burnt sienna that looks more like a painting than a landscape. There is a quality of intensity to the Sahara that is hard to account for simply by reference to the heat or the aridity or the scale. It feels like a place that has been waiting. Not for you specifically, but in a more general sense. A place that has been practicing patience for so long that it has become patience, that the virtue has become a property of the landscape itself. The rock formations of the Tassili Naja have this quality in a particularly concentrated form. The sandstone towers eroded over millions of years into shapes that sometimes seem almost deliberately sculptural. Mushroom forms, arches, pillars, overhangs that create deep pools of shadow even at noon are the framework in which the rock art exists. You walk through these towers in something like the way you walk through a cathedral, aware of a vertical dimension that the outside world usually doesn't have, aware of the history encoded in the stone, aware that what you are walking through is a place that was visited and used and loved by people for whom it was ordinary. The paintings are at eye level or slightly above, where a standing person could reach them. They were made by someone standing where you are standing, someone who looked at the same rock surface you are looking at and saw in it a suitable place to record what they saw. The Tuareg people who have lived in and navigated the Sahara for millennia have a relationship with the desert that is not the relationship of people who have made their peace with hostility and decided to endure it. It is the relationship of people who understand the desert as a place of specific character and specific memory, a place that was other than it is now, and that contains within it, preserved in rock and sediment and the deep mineral memory of the land, the traces of that otherness. Their knowledge of the landscape, their ability to navigate by stars and sand formations and the subtle variations in wind and light, and the behavior of animals that no instrument can detect, is the accumulated knowledge of many generations, passed down through culture and through the cultivation of a particular kind of attention that the desert demands and rewards. It is not the knowledge of people who are merely surviving. It is the knowledge of people who belong. When you talk to Tuareg elders about the Sahara's past, they don't express surprise at the idea that the desert was once green. They nod. They point at features of the landscape, dry valleys, rock formations smoothed by water that hasn't run in 10,000 years, the specific way that certain sand formations sit in basins that were clearly once lake beds, their rims marked by ancient shorelines visible to a trained eye. And they say, with the matter-of-factness of people reporting observed fact, yes, water was here, life was here. It is gone now, but it was here the land remembers. And people who live in a landscape long enough learn to read the memory of the land as fluently as they read the present. There is a fish that keeps appearing in the fossil record of the Green Sahara, and I want to tell you about it because it illustrates in a single species the entire improbable story of what the Sahara once was and what it has become. The fish is Clarius, the walking catfish, a name that sounds like a punchline but is a completely accurate description of a completely real animal. And it has been found in dozens of locations across the Sahara, in places where the nearest water today is hundreds of kilometers away. Clarius is a remarkable animal in ways that go well beyond its locomotion. It is a large catfish. Some species grow to 4 feet and weigh 20 or more pounds, with a broad, flattened head, long barbels, and the characteristic whisker-like sensory organs that give catfish their name. But unlike most large catfish, Clarius has developed an ability that is unique among significant freshwater fish. It can breathe air. Not in the way that some fish can survive out of water for a few minutes by absorbing oxygen through their skin. Clarius has a specialized organ in its gill chamber, a labyrinthine structure of richly vascularized tissue that acts as a primitive lung, allowing the fish to extract oxygen directly from air with enough efficiency to survive out of water for extended periods. Hours in cool, humid conditions, somewhat less in the dry heat of a sub-Saharan afternoon. It uses this ability to do something that no large freshwater fish does in quite the same way. It walks. Not gracefully, and not fast. It uses its pectoral fins to drag itself across dry ground, undulating its body and pushing with the stiff, spine-reinforced fins, covering meters per minute across surfaces that would kill any other large fish in minutes. It walks from a drying water body to find a wetter one. It walks to avoid predators. It walks occasionally into fishing villages and across roads and into houses, which does not endear it to the humans involved, but does make it one of the more memorable fish anyone has ever encountered. The Saharan fossil specimens of Clarias include individuals several feet long, fish of a size that would have represented substantial and reliable food for the people who lived beside the waters they inhabited. The presence of Clarias across the Sahara tells you that the lakes and rivers of the Green Sahara were not marginal, barely alive water bodies struggling to support minimal life. They were rich, well-oxygenated, biologically thriving systems, the kind of productive water that characterizes the great African lakes, where fish grow large and abundant and form the dietary foundation of human communities that have lived beside them for millennia. But Clarias does something else that makes it a particularly evocative symbol of the Green Sahara's legacy. In the rare permanent water sources of the modern Sahara, in the ancient oases, in the few wadis that flow year-round, in the remote mountain springs of the Hogar and Tibesti massifs, you can still find Clarias. Populations of walking catfish cut off from all other water by hundreds of kilometers of desert, surviving in pools so small that their entire world might fit in a suburban backyard. These fish are the last survivors of the Green Sahara's aquatic world. They were there when the lakes were vast. They survived the drying, retreating with the water to the last permanent sources, adapting to conditions of increasing scarcity with the flexibility that makes them one of the most remarkable animals in Africa. They have been isolated in those remote pools for 5,000 years or more, their populations shrinking over the generations as their habitat shrank, maintaining their presence in the Sahara by the most minimal margin, holding on in the remnant water of a desert that was once their home. They are walking, slowly, persistently, across a landscape that has spent 5,000 years trying to kill them, in the direction of a future that none of us can quite see from here. The most recent and perhaps most exciting frontier in Green Sahara research is the direct analysis of ancient DNA, the genetic material preserved in the bones and teeth of the people who lived in the Green Sahara, which can now be extracted, sequenced, and compared with the DNA of modern human populations to reconstruct ancient movements and relationships with a precision that no other line of evidence can match. Ancient DNA research is a young field in the deepest sense. The ability to reliably extract and sequence usable ancient genetic material from skeletal remains has only been possible for about 2 decades, and the field has been transformed multiple times in that short period by new technologies that suddenly made possible analyses that were previously unimaginable. The technical challenges are formidable. DNA degrades over time, broken down by enzymatic activity, by water, by heat, by the chemistry of burial environments. Hot, dry burial conditions like those found in most Saharan sites are in some respects better for DNA preservation than the wet, acidic conditions of temperate soils, which tend to destroy nucleic acids within decades. But the same dryness that protects DNA from enzymatic degradation can also cause dehydration damage, and the high UV exposure in desert environments can cause photochemical damage. Every ancient DNA sample is a gamble. You extract the material, you build sequencing libraries from whatever survives, and you hope that enough authentic ancient DNA is present to produce usable results after computationally separating it from the modern DNA of the researchers and microorganisms that inevitably contaminate the sample. When ancient DNA from green Saharan individuals has been successfully recovered, the results have been transformative. The individuals buried at Gobero, some of whom have yielded DNA of remarkable quality given their 9,000-year age, cluster with modern sub-Saharan African populations in some analyses, consistent with the idea that the Green Sahara was populated in part by people moving north from sub-Saharan Africa following the advancing monsoon. But they also show genetic affinities with ancient North African populations and, intriguingly, with ancient populations from the Near East. Genetic signatures that suggest the abundant resources of the humid Sahara attracted people from multiple directions, who met and mixed at the lakes and rivers of the green world, creating a human genetic diversity in the Sahara itself, that then dispersed when the Sahara dried, carrying the mixed genetic heritage of the Green Sahara in every direction it sent its refugees. The ancient cattle bones from Green Saharan sites have also been genetically analysed, with results that support the hypothesis of an African contribution to cattle domestication. The genetic composition of ancient Saharan cattle differs from the composition of Near Eastern domestic cattle in ways consistent with the independent contribution of African wild aurochs to the African domestic cattle gene pool, a finding that aligns perfectly with what the rock art has been suggesting for decades. The ancient cattle DNA is saying the same thing as the ancient paintings. These animals have an African history that is their own, not merely a copy of a Near Eastern history. Together, the human ancient DNA, the animal ancient DNA, the archaeological evidence, and the climate record are producing a synthesis of the Green Sahara's history that is more detailed, more nuanced, and more compelling than any single line of evidence could produce alone. The past is legible. We are learning to read it. I want to ask a question that might seem cruel, but that I think is important. Could the people of the Green Sahara have done anything to stop what happened to them? Could they have saved their world if they had known what was coming? The answer is almost certainly no. Not because they lacked intelligence or creativity or the capacity for collective action. They clearly had all of these, as the rock art and the burial practices and the trade networks and the cattle herding and the social organization of the lakeside communities all demonstrate. Not because they were incapable of perceiving changes in their environment. They were extraordinarily observant, as people who depend on detailed environmental knowledge for their survival always are. But because the forces that destroyed the Green Sahara operated at scales and on timescales that were entirely beyond the capacity of any human society of any era to perceive or to influence. The orbital mechanics that drove the African humid period were determined by the physics of planetary motion, operating on cycles of thousands of years. An individual human lifetime is 70 years if everything goes well. In the context of a process operating on 10,000-year cycles, 70 years is noise. A person living through the slow drying of the Green Sahara between 7,000 and 5,000 years ago would have experienced change that was, from their perspective, barely perceptible. A degree of interannual variability that was perhaps slightly more variable than their grandparents had described. A memory that the wet seasons had been a bit more reliable a generation back. A subtle shift in where the best grazing was found. Not the end of the world. Not the signal of an irreversible trend. Just the ordinary variability of a life lived in a semi-arid landscape. The vegetation rainfall feedbacks that amplified the drying were driven by the fundamental properties of the Earth's climate system, properties that no technology available in the Neolithic, or for thousands of years afterward, could have influenced or managed. The tipping point, when it came, was the product of feedbacks that had been building for centuries, and nothing any human community could have done would have been sufficient to prevent it. Even if every person in the Green Sahara had understood perfectly what was happening, had somehow had access to the kind of climate modeling capability that didn't exist until the late 20th century, they would not have had the means to act on that understanding. The machinery was too large, the timescales were too long, the complexity was too great. They could not have known. They could not have stopped it even if they had known. This is the part of the story that connects most directly to the present, and it connects in the most uncomfortable possible way, because we are not in the situation of the people of the Green Sahara. We are in the opposite situation. We understand the mechanisms, not perfectly, not without significant remaining uncertainty, but in the broad strokes and in many of the details. We can model the feedbacks. We have the sediment cores that show us what tipping points look like in the geological record, and we have the climate models that show us where the tipping points in our current system are and what pushing towards them does. We have, in the story of the Green Sahara itself, one of the clearest demonstrations available in the geological record of what those feedbacks can do when they start running in the wrong direction. We have the warning. We have the understanding. We have the window of agency that the people of the Green Sahara never had. The question of whether we will use it, whether we will act on the understanding, make the choices, absorb the costs, build the systems that the physics is telling us we need, is not a scientific question. It is a political and moral one, and it is ours to answer. One of the most fascinating aspects of the Green Sahara story is what it reveals about how human cultures encode and transmit information about environmental change over timescales that exceed the lifespan of any individual or any living memory. The rock art is one answer to this challenge. By painting the animals they hunted, the water they depended on, the rituals that organized their communities, on surfaces of rock that would outlast any individual, any community, any civilization, the people of the Green Sahara were creating a form of external memory, a cultural archive encoded in the most durable medium available to them, with the most universally legible language available to them, images that could transmit information across generations indefinitely. The rock art tradition of the Sahara extended for thousands of years without significant interruption, updated and expanded and revised by each generation of artists who found in the same walls the best available medium for recording their world. Cultures changed, languages changed, the specifics of belief and social organization changed. But the tradition of putting the world on the rock walls continued, passed from painters to painters across the entire span of the African humid period and beyond, creating a continuous document of environmental change that spans more than 10,000 years and covers an area the size of a continent. No other human cultural tradition has left behind a comparable environmental record. The pyramids of Egypt are impressive, but they tell you about the pharaohs. The Saharan rock art tells you about the hippos. It tells you about the cattle. It tells you about the dancing figures at the edge of the lake. It tells you what the world was, which is a different kind of knowledge and, in some ways, a more important one. But the rock art is only one of the ways the Green Sahara has transmitted its existence to us. The sediment cores are another, an archive created not by human intention, but by the simple physics of particles settling through water, preserving pollen and bones and isotopic information with a faithfulness that no human archiving system has yet achieved. The buried river systems revealed by radar are another. The Green Sahara writing its geography in the rock, in channels carved deep enough to survive 5,000 years of burial and to be readable from space. The fossil aquifers are another, the Green Sahara writing its existence in water, preserving not just the record of its rainfall but the rainfall itself, still available to drink if you know where to drill. Together, these archives constitute something remarkable. A civilization that left no writing, no cities, no monuments in the conventional sense, and yet managed to preserve its existence across 10,000 years, in enough detail that we can reconstruct not just the broad outlines of what it was, but the specifics, the species of fish its people ate, the posture in which they buried their children, the particular horn shape of the cattle they herded, the exact timing in different regions of the transition from green to desert. The people of the Green Sahara didn't intend to leave a message for us, but they left one anyway, written in every medium available: stone and sediment and water and bone and pollen and gene. The message is the same in every medium. We were here. This was alive. This was green. This was home. Remember us. The least we can do, having received that message, is to remember. Not just as an intellectual exercise, not just as the consumption of an interesting story, but in the deeper sense of acknowledging that these were people, fully human, fully complex, fully alive, who built lives and communities and cultures in a world that no longer exists, and whose lives and communities and cultures matter to the human story in ways that we are only beginning to fully appreciate. They are part of the story of how we got here. Their cattle are in our agriculture. Their genes are in our bodies. Their cultural memory is in our myths. Their fossil rain is in our crops. They gave us more than they knew. We owe them the acknowledgement of their existence. I want to take you through a year in the Green Sahara, because the abstract scientific facts of the African humid period become something different when you try to inhabit them at the scale of a human life. When you ask not what the climate was, but what it felt like to wake up in it, to move through it, to depend on it for everything. This is necessarily speculative in its details, because the archaeological record doesn't tell us what a particular dawn smelled like, or how the wind moved at the edge of a lake in the late afternoon. But the broad facts are well enough established that we can reconstruct, in reasonable outline, what the seasonal cycle of the Green Sahara looked like, and what that cycle meant for the people who organized their lives around it. In the northern Sahara, in what is now Libya and Algeria and Morocco, the year would have had a rhythm not entirely unlike the Mediterranean climate of today, but moister, more forgiving, more alive. The winter months would have brought cool temperatures and reliable rainfall from Atlantic weather systems that pushed south into North Africa with a force and frequency that the modern Sahara rarely experiences. Rain in the Sahara today is associated almost entirely with summer, with the monsoon that still briefly pushes north into the Sahel. But during the African humid period, the winter rainfall belt of the Mediterranean extended hundreds of miles further south, bringing a cool season wet period to the northern Sahara that supplemented the summer monsoon rains and ensured that there was rarely a month entirely without moisture in some part of the region. The mountain ranges that project above the Saharan plateau, the Atlas in the north, the Hoggar in the center, the Tibesti in the south, would have caught orographic rainfall from both the Mediterranean winter storms and the summer monsoon, maintaining springs and streams that flowed year-round and kept the vegetation in these refugia perennially green even during the driest years. Spring in the central Sahara would have been one of the most extraordinary times and places in the natural world. The grasses that covered the plains would have come into their most intense growth after the winter rains, green and thick and rolling in the winds that swept across the open landscape. The migratory animals, the vast herds of wildebeest and zebra, and various antelopes whose East African descendants still make their famous annual migrations, would have moved north with the new growth, spreading across the greened plains in numbers that would have made the ground shake under their collective weight. The predators followed the herds, lions in prides, leopards working the edges of the woodland, cheetahs using the open plains for the long pursuit that their extraordinary speed made possible. The birds would have been overwhelming in their diversity and abundance. The Saharan lake systems during the humid period would have been among the most important waterfowl habitats in the world, visited by millions of migrating birds moving between sub-Saharan Africa and Europe. Summer brought the monsoon, and the monsoon brought a different kind of abundance. The rains were often intense. The ITCZ systems that drive the African monsoon produce rainfall that is characteristically heavy and concentrated rather than gentle and distributed. The kind of rain that fills dry channels in hours, that turns dusty plains into temporary lakes overnight, that floods the lowlands around the permanent lakes, and creates vast, shallow wetlands, teeming with frogs and insects and the birds that feed on them. The humans of the Green Sahara would have organized their movements around the seasonal rhythms of this water, following the herds to the summer pastures, fishing the seasonal floods, harvesting the wild grasses and tubers and other plants whose productivity peaked in the weeks following the monsoon rains. Summer in the central Sahara would have been hot. The Sahara has always been near the equator, and the sun has always been powerful there. But the moisture would have made it bearable in ways that the modern desert's absolute aridity does not. Autumn would have been, in the Green Sahara's seasonal cycle, the season of abundance. The moment after the monsoon when the grasses were at their peak height and seed production, when the lake levels were at their highest after a summer of rainfall, when the fish were fat and abundant in the warm, productive waters, when the herds were heaviest after months of good grazing, when the wild plants were in their maximum fruit and seed production. This would have been the season of gathering, of processing, of storing. The season when the communities of the Green Sahara built up the reserves that would carry them through the dry months of late winter and early spring before the next rains arrived. It would have been the season of ceremony, of celebration, of the dances and rituals that the rock art depicts with such loving detail. A season, in the fullest sense, of life. And then the dry season, the months from late autumn through winter when rainfall diminished or stopped entirely, when the seasonal grasses dried and turned golden, when the migratory herds moved south ahead of the drying conditions, when the lakes shrank back from their flood season margins to their permanent cores, when the people who depended on the seasonal resources moved and adapted as they had moved and adapted for 10,000 years. Not a crisis season, a managed season, a season built into the rhythm of a life that had been organized around its demands for so many generations that its demands were known and anticipated and accommodated in the architecture of human culture itself. The Green Sahara was not a place of perpetual summer. It was a place of seasons, of rhythms, of the ancient alternation of abundance and scarcity that life in all but the most perfectly stable environments requires its participants to manage. They managed it well, for 6,000 years. The southern coast of the Mediterranean was a very different place during the African humid period than it is today, and the difference matters both for understanding the full extent of the Green Sahara and for understanding the connections between the Green Sahara and the civilizations that emerged around the Mediterranean in the millennia that followed its end. Today, the lands of Morocco, Algeria, Tunisia, and Libya south of the Atlas and Jebel Nefusa ranges are, with the exception of occasional river valleys and scattered oases, essentially desert. The strip of productive Mediterranean climate land is narrow, confined to the coastal ranges and the immediate coastal plain, and grades almost immediately into semi-arid scrubland and then into full desert as you move inland even a short distance. The Sahara comes almost to the Mediterranean coast. During the African humid period, this was not the case. The monsoon that pushed so far north in the central Sahara also affected North Africa's Atlantic and Mediterranean fringe, amplifying the already wetter-than-today conditions of the winter rainfall zone and extending productive savanna and woodland vegetation hundreds of kilometers further south than the modern productive zone extends. The Atlas Mountains themselves, the great ranges of Morocco and Algeria that form the northern barrier of the Sahara, were covered in forests during the African humid period to an extent that their current vegetation gives no hint of. Cedar forests extended much further down the mountain slopes. Rivers ran more consistently from the high Atlas to the sea. The great inland basins of Morocco and Algeria, the Moulouya Valley, the high plateaus of Algeria, the great Chots of Tunisia, contained lakes and marshes and productive wetlands that have been dry for 5,000 years. The Roman province of Africa, the granary of the empire, the source of the vast quantities of wheat and olive oil that fed the city of Rome for centuries, occupied much of what had been, a few thousand years earlier, the northern frontier of the Green Sahara. When the Romans were growing wheat in the fields of what is now central Tunisia, those fields were productive because the climate was wetter, and the soils were deeper and richer than they are today. Wetter and richer partly because of the residual effects of the Green Sahara's abundance on soil development and groundwater tables that hadn't yet fully equilibrated to the post-humid conditions. Roman agricultural writers describe North African soils and vegetation with a lushness that the modern visitor to the same landscapes would find hard to reconcile with the scrubby, degraded, heavily eroded terrain they now present. The Romans were farming the lingering afterglow of the Green Sahara, and they farmed it so intensively, with so little attention to maintaining the conditions that made it productive, that within a few centuries the afterglow had faded. The forests of the coastal ranges were logged. The soils were exhausted by continuous cropping without fallow. The livestock overgrazed the marginal lands at the edge of the productive zone. And the Sahara, which had been held at bay by the residual moisture and vegetation density of the post-humid period, began to advance. This is a pattern that recurs throughout the history of North African and Near Eastern civilizations. The exploitation of an agricultural surplus built on the lingering fertility of a wetter climate, followed by the gradual decline of that fertility as the exploitation exceeds the rate of natural restoration. The Fertile Crescent, the great arc of productive land from the Levant through Mesopotamia that was the cradle of Near Eastern civilization, was green in the ancient past, partly because the African humid period extended its moisture influence into the eastern Mediterranean and the Arabian Peninsula, raising groundwater tables and supporting vegetation cover that has since been lost. The salinized fields of modern Iraq, the eroded hillsides of Lebanon and Syria, the desertifying rangelands of Jordan. These are the endpoints of a process that began with the end of the Green Sahara and was accelerated by millennia of intensive human use of landscapes whose ecological capital was never replenished. The Green Sahara's end was not just a Saharan story. It was a story that played out across North Africa and the Near East, wherever civilizations built their futures on the inherited fertility of a wetter past. I want to end this section of our story by pulling back from the specific details, the sediment cores and the pollen records and the ancient DNA, and looking at the Green Sahara from the widest possible perspective, asking the question that is perhaps the most important one of all. What does it mean for us living today that the Sahara was once green? The most literal answer is genetic. If the ancient DNA evidence is correct, and it is becoming more compelling with every new sample analyzed, then the mixing that occurred in the Green Sahara during the African humid period contributed to the genetic composition of human populations across a wide swath of the globe. The people who moved through the Green Sahara and met at its lakes and rivers and mixed their genes and their cultures, and then dispersed when the Sahara dried, they are in us. Their genetic legacy is part of the genetic inheritance of every human being alive today who has North African, Near Eastern, East African, or European ancestry. The Green Sahara was one of the great mixing bowls of human prehistory, a place where populations that had been separated by desert during the dry periods came together during the wet, and the mixture that resulted flowed outward from the Sahara in every direction when the wet period ended. We are all, in a real genetic sense, partly children of the Green Sahara. The cultural legacy is harder to trace in the scientific record, but may ultimately be more significant. The transition from the Green Sahara to the desert pushed people into the Nile Valley, the Levant, and sub-Saharan Africa, carrying with them the accumulated cultural capital of 6,000 years of abundance. The cattle-herding traditions, the astronomical knowledge, the artistic conventions, the social structures, the technological innovations. Some of those traditions flowed directly into the earliest civilizations, the cattle culture into Egypt, the astronomical knowledge into Nabta Playa, and then into the pyramid-building culture that treated celestial alignment as a fundamental principle of sacred architecture, the artistic traditions into the earliest Egyptian pictorial art. Others dispersed into sub-Saharan Africa and became the foundations of the great cattle-herding cultures that persist there today. The Green Sahara was not a separate chapter of human history, unconnected to the main narrative. It was a central chapter, a formative one, a chapter whose ending provided the conditions for some of the most significant cultural developments in the human story. The ecological legacy is the most urgent. Every drop of fossil water pumped from a North African aquifer is Green Sahara water. Every crop grown in the Libyan and Egyptian desert interior is watered with Green Sahara rain. The soils of the Sahel retain, in their organic matter and their mineral composition, the legacy of the vegetation that the Green Sahara supported. A legacy that is being diminished by overuse and climate stress, but that still makes the Sahel more agriculturally productive than it would otherwise be. The fish in the oasis pools of the Central Sahara are Green Sahara fish, survivors of a biological world that was once immeasurably richer. The sand dunes that march across the Sahara today are, in part, the redistributed soil of the Green Sahara. The minerals and organic matter of a once living landscape broken down and blown into the Atlantic and the Mediterranean and the Amazon, where they fertilize living systems on a scale that makes the Green Sahara, 5,000 years after its death, still one of the most ecologically significant landscapes on Earth. And the psychological legacy is perhaps the most profound of all. The knowledge that the Sahara was green, that this place that seems to us the archetype of lifelessness and hostility was once one of the richest, most productive, most densely human-inhabited landscapes in Africa, changes something fundamental about how we see the world and our place in it. It tells us that the present is not the permanent. It tells us that landscapes we have written off as irredeemable can, given the right conditions, explode into life. It tells us that the boundaries we draw between the living world and the dead world, between the possible and the impossible, between the green and the desert, are not fixed. They move. They have moved before. They will move again. The question is always, which direction? And who decides? We decide. That is both the burden and the extraordinary privilege of living in the first species that knows enough to ask the question. The people of the Green Sahara did not get to decide. The forces that shaped their world were beyond their knowledge and beyond their reach. We are different. We have their story. We have their bones and their paintings and their fish and their fossil rain. We have the science to understand what happened to them and why. We have, if we choose to use it, the capacity to make different choices than the ones that drove us here. The Green Sahara is not just a story about the past. It is the most important story about the future that the geological record contains. And it is addressed with an urgency that 10,000 years of sand have done nothing to diminish, directly to us. So here we are at the end of the story, or rather at the beginning of the understanding of it, because the science of the Green Sahara is still young, and the discoveries are still coming. Every year, new expeditions bring back new evidence. New satellite data reveals new river systems under the sand. New sediment cores tell more detailed stories of the world that was. New archaeological sites emerge from the sand as wind erosion exposes what centuries of burial had concealed, revealing the artifacts and bones and structures of communities that lived and died and built their lives in a Sahara that no longer exists. Ancient DNA labs sequence the genomes of people who lived in the heart of the desert 10,000 years ago, and find in those genomes the signatures of movements and mixings and adaptations that rewrite what we thought we knew about African human history. The picture is getting clearer every year. Every year, the Green Sahara comes more sharply into focus. Every year, the lost world comes a little further back from the dead. The picture that's emerging is of a world so rich, so productive, so teeming with life that it reshapes our understanding of Africa's past, and, through Africa's past, our understanding of human history itself. A world of hippos and crocodiles and vast lake systems and rock art cattle herds, and the woman buried with her children in an embrace that lasted 9,000 years in the dry sediment of a lake that was already a memory by the time the first Egyptian pharaoh was born. A world that produced cultures of extraordinary sophistication and creativity in a landscape that we have spent centuries dismissing as empty, as barren, as the archetype of lifeless waste. The Sahara was never simply empty. It was full, and then it was emptied, and the emptying was a tragedy of the first order. A loss of biodiversity and human cultural complexity and accumulated knowledge and irreplaceable life that ranks with any extinction event in the human record. I want to be clear about what was lost, because I think we have a tendency to process this kind of information at a distance that prevents it from landing with its full weight. What was lost when the Green Sahara died was not just a climate regime or an ecosystem type. What was lost was everything that had been built on top of those physical conditions. Every language that had developed in the Saharan communities, now gone with no record beyond a few artistic conventions that we can identify but not speak. Every story that had been told around every fire at the edge of every lake, now vanished as completely as the lakes themselves. Every body of knowledge about plants and animals and weather and seasons and human relations that had been accumulated over 6,000 years of intensive and observant living in one of the richest landscapes in Africa. The knowledge of which plants grew at which time, at which elevation, following which sequence of rains. The knowledge of where the fish concentrated in the warm shallows and in the deep, cold channels. The knowledge of how to read the behavior of the migratory herds to predict their movements. The knowledge of how to manage cattle across a landscape of seasonal variation, moving them to the right grazing grounds at the right time. All of this, accumulated over generations beyond counting, refined and tested and corrected over millennia, was lost when the people dispersed and the communities broke apart and the landscape that the knowledge was specific to ceased to exist. It is gone. We cannot recover it. We can only look at what it produced. The rock art, the burial practices, the cattle herding traditions, the genetic legacy, and try to imagine, from the products, what the knowledge itself must have been. But the Green Sahara is not just history. It is a warning and a mirror and a possibility all at once. It is a warning because it shows us, with the clarity of geological evidence rather than political argument, how completely, how suddenly, in geological terms nearly instantaneously, a world can end. How a landscape that supported millions of people and billions of animals can become, in the span of a few thousand years, one of the most inhospitable places on Earth, driven by feedbacks that amplified a modest initial forcing into a catastrophic and nearly irreversible state change. The warning is not abstract. It is not a warning about some distant future possibility. It is a warning about something that already happened once in our own species' history, in living human cultural memory, if not in living human personal memory. It happened. We have the bones, we have the pollen, we have the sediment cores. The warning is written in physical reality, not in models or projections, and it is addressed to us with a specificity that models and projections cannot match. It is a mirror because we can see in the Green Sahara's story the reflection of our own situation with uncomfortable clarity. We are stressing the Amazon and the Sahel and the boreal forests and the Southeast Asian peatlands and dozens of other vegetation rainfall coupled systems in ways that risk triggering the same kind of self-reinforcing collapse that destroyed the Green Sahara. And we are doing it with the added acceleration of direct greenhouse warming that the Green Sahara's collapse never had. We are running a faster version of the same experiment that the orbital mechanics ran on the Green Sahara, with the added complication that we are running multiple versions simultaneously on multiple continents. The feedbacks don't care whether the forcing comes from orbital mechanics or from carbon dioxide. They work the same way, regardless of the cause of the initial warming. The tipping points are in the same place whether the push comes from Milankovitch cycles or from the exhaust pipes of a billion vehicles. And it is a possibility because the Green Sahara also shows us what the land can become when it is given what it needs. When the orbital forcing pushed monsoon rains north, the Sahara responded with an explosion of life so extraordinary that it built civilizations, fed millions, and painted the story of its own abundance on the walls of rock that still stand in the desert today. The land knows how to be green. It carries the memory of greenness in its soils and in the root systems that wait underground and in the aquifers full of ancient rain. Given the right conditions, given enough moisture and enough time and enough protection from the pressures that have been stripping it of its capacity for recovery, it will respond. It always responds. That is what the Green Sahara shows us most clearly of all. The land is not passive. It is not a backdrop. It is a participant, a partner, a system capable of extraordinary, positive responses to improving conditions, capable of amplifying the smallest increases in moisture into something vast and alive and sustaining. We don't need to recreate the orbital configuration of 11,000 years ago to set those responses in motion. We need to give the land the protection it needs, and the moisture it needs, and the time it needs, and then step back and watch what the Earth already knows how to do. The woman buried with her children at Gobero 9,000 years ago lived in a world she assumed would last forever. It didn't. We live in a world we assume will last forever too. The difference, the only difference that matters, is that she had no warning, no understanding of the orbital mechanics that would slowly withdraw the rain from her world. No way to see the tipping point coming before it arrived, and took everything she knew. We have the science, we have the warning, we have the sediment cores and the satellite data, and the fossil hippo bones, and the rock paintings of cattle, in what is now the driest place on Earth. We have the ancient DNA of the people of the Green Sahara, sequenced in laboratories on 4 continents, telling us who they were and where they came from and where they went. We have, preserved in the sand of the Sahara, one of the clearest messages that the geological record has ever delivered to a species capable of reading it. The message is this: everything you think is permanent is temporary. Everything you think will always be there might vanish in a geological eye blink. The world you love is more fragile than you know, and the tipping points are closer than they look, and the time to understand that, the time to act on it, is not when the lakes are already drying, and the rivers are already ghosts, and the people are already moving. It is now, while the world is still green. The Green Sahara lasted 6,000 years. It left behind 10,000 years of evidence. It is still here if you know how to look, in the buried rivers visible from space, in the fossil water under the desert, in the bones of a woman and 2 children, arranged in an embrace that has outlasted every civilization that ever looked at the desert and called it permanent. The desert was not always there. The desert will not always be there. What comes next is, for the first time in the history of the Green Sahara story, up to us. If this story moved you, if the ghost of the Green Sahara changed the way you see the world, even slightly, even for a moment, please subscribe. Not for the algorithm, not because the channel needs the numbers, though it does, but because there are dozens more stories like this one. Stories of worlds that existed and vanished without a monument. Stories of civilizations that rose and fell and left their only testimony in the bones of fish in the desert and the paintings of hippos on rock walls. Stories that the science is only now learning to read, and stories that matter. Not as curiosities, not as trivia, but as evidence about what the Earth is, and what it does, and what it's capable of, both in creation and in loss. Hit subscribe. Leave a comment telling me where you're watching from and what time it is. I read every single one, and the geography of this audience, the spread of it across the world, is one of the things that gives me the most genuine hope. If you know someone who needs to hear this story, a student, a teacher, a parent, a person who loves the world and worries about it, send it to them. The Green Sahara existed for thousands of years before anyone alive today was born. It fed millions of people and painted their lives on rock and buried their children with love in the sediment of lakes that no longer exist. The least we can do is remember it. And maybe, in the remembering, find the will to protect what we still have before it becomes a memory too. Thank you for watching. The world is stranger and more beautiful than we know, and we are only beginning to understand what we have lost and what we still have left to